to start flying. The flight path is randomly generated. Jump out the plane and start free falling. Control the pitch angle and change the fall speed. Control the yaw angle and change the lateral speed. Open the parachute and start gliding. When gliding, you can still use the W, A, and D keys to control flight direction. Character poses are divided into standing, crossing, and pole. Each pose allows for jogging, walking, and running. The character moves at different speed for different poses and movement states. The three directions forward have the same speed and faster. Same speed to left, right, and back three directions, slightly slower. This complex character animation system is implemented through an animation state machine. These items are randomly generated. These items are all items. The object system is vast, and I will build a complete object architecture for all object functionality. Pick up the equipment will show up on the character. All items can be operated in the inventory UI, and you can equip the accessories to the weapon. All actions are synchronized in real time, not only to the characters in the scene, but also to the characters in the UI. We have a total of 2 consumables available. One is an energy object, increases the energy value after use, slowly restoring life value. The other is a health restoring item. Health values restored directly after use. All weapons have 2 ways of aiming. One is to aim directly, and the other is to aim with the sights-on. Each time for fire, there is a shake, and each weapon have a different shake ring. Weapon accessories can affect how much a weapon shakes. The weapon can also be equipped with a scope. The rounds fired will have a downward effect. The safe zone feature will be implemented when the game starts. Every period, a new location will be randomly located within the current safe zone. When the character is outside the safe zone, it will continue to consume health points. Every once in a while after the game starts, the system will bombard you. At range, keep bombing for a while. Blast points are randomly generated. If the character is within the blast range, they lose health point. The game will start with an airdrop now and then. The drop location will be random within the safety zone. The drop box will contain random items according to the rules. The features implemented in the course are very detailed, and there is a lot of detail is not shown in this video. It will be explained in detail in some key and difficult areas. This course is positioned as an introductory course, and all content is created using Blueprint, so you can learn whether you have programming experience or not. All of the functions used in the Blueprint are C++ behind it, so even if all of your work is done in C++, this tutorial will still help you a lot. It was a pleasure to next session. The engine gave us many different types of game templates by default, which will be very useful for you if you are a beginner. Select the back item. Choose whether to create a Blueprint or C++ project. Choose the closest equivalent target platform. Select desktop or console. This option allows you to select the quality. Choose the maximum quality. This option enables a simple placeable grid with an additional content pack containing basic materials and textures. We don't need the contents. The last one, whether or not to enable ray tracing. Select not turning on. You can set whether or not to turn on ray tracing at any time after entering the project. Set the project name to pubg Blueprint. Click the Create Project button. After the project is created successfully, open the folder where the project is located. Copy the resources downloaded in the previous lesson into the project. Open the project. Resource import was successful. That's it for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. This lesson will explain to you the content of the resources. There are 2 folders in total. The Maps folder is the same resources. Open Level Battle. This is the final scene. Click Play. The game takes a long time to start. This is because this scenario is large. During the development process, you will run the game frequently to check the functional effects. To increase the efficiency of the development process, there is another thing. Open Level Test. Click Play. This scenario will start the game faster. Open the Assets folder. This is where all the resources are located. The Animations folder holds all the animation files. The Audio folder contains all the audio files. The Font folder contains the font files. The Human folder contains the character resources. These include character models, materials, clothes models, and materials for custom changes, and so on. The Icons folder contains all the icon files. The Maps folder contains all the resources you need to build your scene. The other folder contains resources that cannot be categorized precisely. The Outline folder contains the resources you need to create an item's outline. The Parachute folder contains parachute-related resources. The Particles folder contains all the particle resources. The Pub folder contains 3D-related resources for all items. The Safe Zone folder contains resources related to safe zones. The UI folder contains the images used to create the UI. The Vehicle folder contains resources about the aircraft. The Weapon folder contains resources for all weapons. This includes files related to the weapon's model. There are also resources for all weapon accessories. Some weapons have exclusive accessories, which are placed in the Weapons folder. That's all the resources we'll be using. That's it for this lesson. Thanks for watching, and we'll see you. Hello everyone, I'm Big Cat. This lesson gives you a brief explanation of the engine editor interface. At the top, you can switch between screens by clicking on them. Drag and drop to display the interface independently. Below is the menu bar. The Field menu has many new and sales-related functions. The most important in the Add menu are the Editor Preference and Project Settings and Plugin Settings. The Window menu can choose to show and hide the various windows. The Help menu can jump to the documentation. Click Editor Preference. Here you can set the global engine functions. The settings are not for a project, but all projects. Click Project Settings. Here you can set the settings for the current project. In the Content Browser window, you can browse all the resources of the current project. The center position is the viewport of the scene. The default state in the perspective mode. Click this button to switch to another model view. Clicking this button divides the view into 4 windows to be displayed simultaneously. This is the World Outline panel. All the contents of the scene can be found here. Double-click on an object to locate it in the scene. Here, you can create folders to categorize your resources. Right-click on an object to operate on it. enter a keyword in the search field to search. This is the Details panel. When we select an object, the information for that object is displayed in this panel. Click on Blueprint button and click to open Level Blueprint. Here, you can program the blueprint. These are the most basic panels, and many others will be used throughout the game development process. The use of each of these panels will be described in detail later in the development process. That is for this lesson. Thanks for watching, and we'll see you next. Hello everyone, I'm Big Cat. This lesson explains to you how to run the game. The first way is to run directly in the scene viewport. There is a play button here. Click on this button to run it directly in the viewport. After running, the mouse cursor disappears and the focus comes into the scene. Press Shift plus F1 key to show the mouse cursor. Mouse click anywhere in the same view. The mouse cursor will be hidden again. The other way is to run in a new window. Click on the little arrow. There are many ways to run it. The first one is the way we just run it directly. The second is to run it using the mobile emulator. The third is to create a new window to run in. The fourth is to run it VR mode. The fifth one is to run it as a completely separate process. The sixth is to run it as a simulation. The most common of these runs is to create a new window to run in. Click on New Actor window. A new window is generated. Click on the small arrow. Click on Advanced Settings. This panel is the Actor Preferences panel. Here, you can set the run-related parameters. Since the resolution we used to create the UI was 1920 by 1080, the resolution of the new window was changed to 1920 by 1080. Play the game. The resolution of the new window is changed to 1920 by 1080. In the Models panel, there is a Player Start object. Drag a Player Start into the scene. Play the game. The initial position has changed. There is another way to locate the initial position quickly. Right-click on the position you want. Click on Play from here. Both of these ways of running the game will be used often later in the development process. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, we'll look at some of the essential elements of the Unreal Engine. First up is the object. The base building blocks in the Unreal Engine are called objects and contain a lot of the essential, under the hood, functionality for your game assets. Just about everything in Unreal Engine inherits from an object. It implements features such as garbage collections, mandate support for exporting variables to the Unreal editor, and serialization for loading and saving. Right-click. Select the Blueprint class. You can see that all types inherit from object. Actor object. This object is often used. An actor is any object that can be placed into a level. Actors are a generic class that supports 3D transformations such as translation, rotation, and scale. Right-click and select the Blueprint class. Create an actor. Open an actor. Write the blueprint in Event Graph. Actor inherits from object, so actor also has functions such as garbage collection. Component can be added to an actor. Components cannot appear alone, and they need to be added to the actor. For example, let's add a static mesh component. This component is used to display the static model. Press the left mouse button and drag and drop it into the blueprint. Drag the node. All the functions of the static mesh component are displayed. Enter Set Static Mesh. This is where you can set his model. In this lesson, we have explained a few essential elements that will be used frequently in future game development, and you will get to know these elements step by step better. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. This lesson will introduce you the game framework gameplay provided by Unreal Engine. Framework relationships. A game is made of a game model and a game state. Human players join the game associated with player controllers. These player controllers allow players to possess pawns in the game to have physical representations in the level. Player controller also give players input controls, a head-up display or HUD, and a player camera manager for handling camera views. From the window menu, click on World Settings. Here you can set up the game model and other objects. The base rules of the game should be stored in game model. The game model object exists only on the server and usually stores information about the game that the client does not need to know explicitly. For example, in our game, an airdrop is replenished now and then. The logic for deciding when to time the drop, calculating the drop's location, and generating the drop's content should be written in the game mode. The client doesn't care how the content is generated, and just notifies the client when the server is done calculated. Game state stores information about the entire game. Game state exists on both server and clients, so the server can use copy variables on game state to keep all clients up to date with the latest game data. For example, in our game, the current status of the number of players remaining, safe zone information, etc. should be stored in the game state. Pawn is the physical symbol of the player in the world. What exactly is pawn? Let's run the project and see. Find the different pawn in the world outline. As you can see in the details panel, this default pawn has a move component. There is also a collision component. You can move with the W, S, A, and D keys. The collision effect will occur when you hit an object. In our game, the player character is required to be shown humanoid characteristics. Use the character object instanced of pawn. Create a character. Character inherits from the pawn object. The character object has a character movement component by default, which allows walking, running, jumping, flying, and swimming around the scenes. There is also a capsule component, which represents the physical size of the character. There is also a skeletal model component, which shows the character skeletal model and allows for the skeletal's advanced animation. Delete the blueprint. The player controller is used to control the behavior of the character. The user input is processed in the player controller, and the commands are then sent to pawn. The player controller is always present in the game. The HUD refers to the status and the information overlaid on the screen during gameplay. The purpose of the HUD is to inform the player of the game's current state. The score there has the amount of time remaining. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. This lesson creates content about the gameplay framework. Create the folder in the content folder. Name it Blueprints. All blueprints for this project are placed in this folder. Create a folder named Gameplay. Gameplay-related blueprints are placed in this folder. Create a folder and name it Character. Blueprints for the character are placed in this folder. Create a blueprint class in the gameplay folder. Select Game Mode Base. Name it MyGameMode. Create another blueprint class. Select Player Controller. Name this as MyPlayerController. Create another blueprint class. Type GameState in the search field. Select GameState Base. Note that you have to select GameState Base instead of GameState here. Name it MyGameState. Create another blueprint class. Type HUD in the search field. Select HUD. Name it My HUD. Create another blueprint class. Tap Player State in the search field. Select Player State. Name it My Player State. Create another blueprint class. Select Character. Name it My Character. Next, set up these blueprints that you just created. Open My Game mode. Set the Game State class to My Game State. Set the Player Controller class to My Player Controller. Set Player State class to My Player State. Set the HUD to My HUD. Set Default Pawn class to My Character. Compile, save. Open the Project Setting panel. Select Map and Mode. Set the default game mode to My Game mode. Set the Editor Start map and the Game Default map to both Level Test. Open the Level Test scene. Add a player start to the scene. Adjust the rotation. Open the World Settings panel. Set Game Mode to My Game mode. Play the game. Now, the WSAD and the mouse are not working because the game mode has been replaced with one we just created, and we haven't made any action logic yet. Next, create game instance. Create a blueprint in the gameplay folder. Tap Game Instance and select Game Instance. Name it My Game Instance. Save. Game Instance is present throughout the application from start to finish. It is possible to do something like scene switching in this class. You can also create some contents here that can be used anywhere. Open the Project Settings panel. Set the Game Instance class to My Game Instance. In this lesson, we have created the relevant blueprint needed for gameplay, which will be gradually improved in later lessons. That is for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. There are many functions in the game that need to be triggered by keyboard keys. Open the Project Settings panel. Select Input. There are two ways to map keys. One is action mapping, which responds to key presses and a key release. It receives a press event when the key is pressed and a release event when the key is released. The other is access mapping, which receives events continuously regardless of whenever the keyboard is pressed or not, with a parameter to determine if the key is being pressed. Here a more intuitive look at both mappings through testing. Click the plus sign. Create an action mapping. Name is Test1. Select the keyboard A key. You can check here if you need a key combination. Open the level. Open the level blueprint. Click the right mouse button in the black base and tap Test1. The Test1 keyboard event you just created will appear. Drag out of press and tap Print. Select Print String. Use this node to print the string on the screen. Enter pressed. Drag out from Released. Enter Print. Select Print String. Enter Released. Play the game. Press the A key and do not relay it. The top left corner of the string prints pressed once. Release the keyboard A key. The upper left corner of the screen prints released once. This is action mapping. Next test the access mapping effect and an access mapping. Name is Test2. Select the keyboard 1 key. Add another key. Select the keyboard 2 key and set the value to 2.0. Open the level blueprint. Add the Test2 event. Add the print node. Print access value. Play the game. The scenes keep reading 0 when I didn't press anything. Press the keyboard 1 key. Print changes to 1. Press the keyboard 2 key. Print changes to 2. This is the axis mapping effect. Delete the test node. This lesson explains the 2 different input events. That is for this lesson. Thanks for watching, and we'll see. Hello everyone, I'm Big Cat. These lessons as input buttons that will be used in the game. Open the key mapping panel. First, add the keys related to action mapping. Delete the test key. Add a mapping named crouch. Press and the character perform the crouch action. Select the keyboard C key. Add mapping named prong. When pressed, the character performs a prong action. Select the keyboard D key. Add a mapping named jump. When pressed, the character performs a jump. Select the keyboard spacebar key. Add a mapping named left shift. Select the keyboard left shift key. Add a mapping named walk. When pressed, the character performs a slow walk. Select the keyboard left control key. Add a mapping named alt. Select the keyboard left alt key. Add a mapping named interaction. Use this key to pick up objects, jump out of plane, or open a parachute, for example. Select the keyboard F key. Add a mapping named discard weapon. Press to execute a weapon throw. Select the keyboard G key. Add mapping named aiming. Press and open the sight. Select the right mouse button. Add mapping named reload. Press and perform a memory change. Select the keyboard R key. Add mapping named fire. Press and execute fire. Select the left mouse button. Add mapping named shoot mode. Press and toggle weapon fire mode. Select the keyboard B key. Add mapping named take back gun. Press to retrieve the weapon. Select the keyboard X key. Add mapping named show inventory. Press to show ahead the access screen. Select the keyboard table key. Add mapping named Toggle Map UI. Press to show ahead the Toggle Map UI. Select the keyboard M key. Add mapping named Keyboard 1. Press to equip the left weapon on the back. Select the keyboard 1 key. Add mapping named Keyboard 2. Press and equip the weapon on the right side of your back. Select the keyboard 2 key. Next, add the axis mappings. Add mapping named move forward. Control the character to move forward or backward. Select the keyboard W key. Add keys. Select the keyboard S key. The value is minus 1.0. Add mapping named move right. Control the character to move left or right. Select the keyboard A key. The value is minus 1.0. Add keys. Select the keyboard D key. Add mapping named turn. A horizontal mouse movement triggers this event. Select the mouse X. Add mapping named look up. A vertical mouse movement triggers this event. Select mouse Y. Add mapping named aiming. Press and hold the aim function to use this event. Select the right mouse button. The keyboard event is added. That is for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. In this lesson, we set up the distance of the camera's near clipping plane. What is the distance of the camera's near clipping plane? In the same viewport, bring the camera close to the object. As you can see, the model will be cupped when the camera approaches the object at a certain distance. It is this distance that we need to adjust. Open the project setting panel. Enter near. The current distance value is 10. Set its value to 1. Note that if you want the set value to take effect, you must restart the engine. In the same viewport, bring the camera close to the object. We can see that this time, the camera is cropped only when it is very close to the object. This value will alter our ability to make weapon size in the future. That is for this lesson. Thanks for watching, and we'll see. Hello everyone, I'm Big Cat. From this chapter, we will start making animation blank space for characters. In this lesson, we will first look at what blank space is. There are two types of blank space, one controlled by one value, and the other controlled by two values. Here's a demonstration to give you more visual understanding. Right-click in the character folder. Select Animation. There are two types of blank space. Select one-dimensional blank space, then select the skeleton. Animations are displayed based on skeletons, so you need to select which skeleton to create an animation for. Select Female, named BS Test 1D. Open. In the top left corner, you can see the access settings. Since we are creating a one-dimensional blank space, there is only one horizontal axis here. The name is the variable name. Name is speed. This means that this horizontal axis is the speed value, the minimum and the maximum values of the horizontal axis. You can see this value in the animated graph. This is the number of grades to divide. The default is 4 grades. The animated graph shows that from 0 to 100, it is divided into 4 sections. Once the axes are set, you can start setting up the animation sequence. There is a resource panel that contains all the animation sequences related to this skeleton to the right. This can be narrowed down by searching for keywords. Drag in the normal stand idle animation to a value of 0. Drag in the normal stand walk animation to a value of 50. Drag the normal stand run animation to a value of 100. The green dot is the input value, which can be changed by changing the animation state. Next, look at the use of 2D blend space. Create a two-dimensional blend space. Named BS Test 2D. Open. In the axis setting, in addition to the horizontal axis, there is an additional vertical axis. Set the horizontal axis. Name it direction. The minimal value is minus 180. The maximum value is 180. Set the vertical axis. Name is speed. Enter stand in the search field. Drag the normal stand idle animation to a person where the direction is 0. Drag the normal stand walk forward animation to a position with direction 0 and speed 50. Drag the normal stand walk left animation to a direction of minus 90 and a speed of 50. You can change the state of the animation by setting the direction and the speed. This is the primary usage of the animation blend space. Delete the test file. That is for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is standing and moving while unarmed. Create a folder in the character folder. Name it blank space. All blank space files are placed in this folder. Right-click in the character folder. Select blank space. Select female. Name it BS normal stand. BS means this is an animated blank space. Normal means unarmed, and stand implies that the character is standing. Open. The horizontal axis represents the character's direction, named direction. The minimum value of the direction is minus 180 degrees. The maximum value of the direction is 180 degrees. The number of grid divisions is 8. The vertical axis represents the character's movement speed and is named speed. Here, it is divided into maximum movement speed and minimum movement speed. Set the maximum value to 625. This indicates that the character's maximum movement speed is 625 centimeters per second. The minimum speed is set to 0. The character's speed is 0 when the character is idle. The number of grids is 12. Next, add an animation sequence to the blank space. Enter normal stand. Show all animations that are unarmed and are in a standing position. Drag the idle to 0 direction and 0 speed. Drag the green dots in the grid to see the effect. Drag the work forward to 0 direction and 156 speed. Drag the work left forward to minus 45 direction and 156 speed. Drag the work right forward to 45 direction and 156 speed. Drag the work left to minus 90 direction and 156 speed. Drag the work right to 90 direction and 156 speed. Drag the work left back to minus 135 direction and 156 speed. Drag the work right back to 135 direction and 156 speed. Drag the work back to 180 direction and 156 speed. Drag the work back to minus 180 direction and 156 speed. Drag the jog forward to 0 direction and 468 speed. Drag the jaw left forward to minus 45 direction and 468 speed. Drag the jog right forward to 45 direction and 468 speed. Drag the jaw left to minus 90 direction and 364 speed. Drag the jaw right to 90 direction and 364 speed. Drag the jaw left back to minus 135 direction and 364 speed. Drag the jaw right back to 135 direction and 364 speed. Drag the jaw back to 180 direction and 364 speed. Drag the jaw back to minus 180 direction and 364 speed. Drag the run forward to 0 direction and 625 speed. Drag the run left forward to minus 45 direction and 625 speed. Drag the run right forward to 45 direction and 625 speed. Drag the run left forward to minus 45 direction and 312 speed. Right-click to set the animation playback rate to 70% of the original. Drag the drone right forward to 55 direction and 312 speed. Right-click to set the animation playback rate to 70% of the original. Drag in the unarmed idle animation sequence at all speeds of 0. This completes the setup of the unarmed standby moving blank space. That is for this lesson. Thanks for watching. Session. Hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is crouching and moving while unarmed. Right-click in the blank space order. Select blank space. Select female. Name it BS normal crouch. Open. The horizontal axis represents the character's direction. Named direction. The minimum value of the direction is minus 180 degrees. The maximum value of the direction is 180 degrees. The number of grid divisions is 8. The vertical axis represents the character's movement speed and is named speed. Here, it is divided into maximum movement speed and minimum movement speed. Set the maximum value to 476. The minimum speed is set to 0. The character's speed is 0 when the character is idle. The number of grids is 12. Next, add an animation sequence to the blank space. Enter normal crouch. Drag the idle to 0 direction and 0 speed. Drag the work forward to 0 direction and 142 speed. Drag the work left forward to minus 45 direction and 142 speed. Drag the work right forward to 45 direction and 142 speed. Drag the work left to minus 90 direction and 142 speed. Drag the work right to 90 direction and 142 speed. Drag the work left back to minus 135 direction and 142 speed. Drag the work right back to 135 direction and 142 speed. Drag the work back to 180 direction and 142 speed. Drag the work back to minus 180 direction and 142 speed. Drag the jog forward to 0 direction and 333 speed. Drag the jaw left forward to minus 45 direction and 333 speed. Drag the jog right forward to 45 direction and 333 speed. Drag the jaw left to minus 90 direction and 238 speed. Drag the jaw right to 90 direction and 238 speed. Drag the jaw left back to minus 135 direction and 238 speed. Drag the jaw right back to 135 direction and 238 speed. Drag the jaw back to 180 direction and 238 speed. Drag the jaw back to minus 180 direction and 238 speed. Drag the run forward to 0 direction and 476 speed. Drag the run left forward to minus 45 direction and 476 speed. Drag the run right forward to 45 direction and 476 speed. Drag in the idle animation sequence at O space of 0. This completes the setup of the unarmed cross to move blank space. That is for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is prone and moving while unarmed. Right-click in the blank space order. Select blank space. Select female. Name it BS normal prone. Open. The horizontal axis represents the character's direction. Named direction. The minimum value of the direction is minus 180 degrees. The maximum value of the direction is 180 degrees. The number of grid divisions is 8. The vertical axis represents the character's movement speed and is named speed. Here, it is divided into maximum movement speed and minimum movement speed. Set the maximum value to 190. The minimum speed is set to 0. The character's speed is 0 when the character is idle. The number of grids is 8. Next, add an animation sequence to the blank space. Enter normal prone. Drag the idle to 0 direction and 0 speed. Drag the work forward to 0 direction and 190 speed. Drag the work left forward to minus 45 direction and 190 speed. Drag the work right forward to 45 direction and 190 speed. Drag the work left to minus 90 direction and 104 speed. Drag the work right to 90 direction and 104 speed. Drag the work left back to minus 135 direction and 104 speed. Drag the work right back to 135 direction and 104 speed. Drag the work back to 180 direction and 104 speed. Drag the work back to minus 180 direction and 104 speed. These are normal speed animations. When the character is moving, pressing the Ctrl key will reduce movement speed. We also use this animation, implemented in a way that adjusts the animation rate. Drag the work forward to 0 direction and 44 speed. Right-click, set the animation playback rate to 41% of the original. Since the character moves at 41% of normal speed when the Ctrl key is pressed, it's set to 0.41 here. Drag the work left forward to minus 45 direction and 44 speed. Right-click, set the animation playback rate to 41% of the original. Drag the work right forward to 45 direction and 44 speed. Right-click, set the animation playback rate to 41% of the original. Drag the work left to minus 90 direction and 29 speed. Right-click, set the animation playback rate to 41% of the original. Drag the work right to 90 direction and 29 speed. Right-click, set the animation playback rate to 41% of the original. Drag the work left back to -135 direction and 29 speed. Right-click, set the animation playback rate to 41% of the original. Drag the work right back to 135 direction and 29 speed. Right-click, set the animation playback rate to 41% of the original. Drag the work back to 180 direction and 29 speed. Right-click, set the animation playback rate to 41% of the original. Drag the work back to -180 direction and 29 speed. Right-click, set the animation playback rate to 41% of the original. Drag the work left forward to -45 direction and 29 speed. Right-click, set the animation playback rate to 70% of the original. This way, the forward to the left animation can be connected. Drag the work forward to 0 direction and 29 speed. Right-click, set the animation playback rate to 70% of the original. This way, the forward animation can be connected. Drag the work right forward to 45 direction and 29 speed. Right-click, set the animation playback rate to 70% of the original. Drag in the idle animation sequence at O space of 0. This completes the setup of the unarmed prone to move blank space. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is standing and moving while armed. Right-click in the blank space folder. Select blank space. Select female. Name it BS Reef Stand. Open. The horizontal axis represents the character's direction, named direction. The minimum value of the direction is -180 degrees. The maximum value of the direction is 180 degrees. The number of grid divisions is 8. The vertical axis represents the character's movement speed and is named speed. Here, it is divided into maximum movement speed and minimum movement speed. Set the maximum value to 600. This indicates that the character's maximum movement speed is 600 centimeters per second. The minimum speed is set to 0. The character's speed is 0 when the character is idle. The number of grids is 8. Next, add an animation sequence to the blank space. Enter Reef Stand. Show all animations that are armed and are in a standing position. Drag the idle to 0 direction and 0 speed. Drag the work forward to 0 direction and 150 speed. Drag the work left forward to -45 direction and 150 speed. Drag the work right forward to 45 direction and 150 speed. Drag the work left to -90 direction and 150 speed. Drag the work right to 90 direction and 150 speed. Drag the work left back to minus 135 direction and 150 speed. Drag the work right back to 135 direction and 150 speed. Drag the work back to 180 direction and 150 speed. Drag the work back to minus 180 direction and 150 speed. Drag the jog forward to 0 direction and 450 speed. Drag the jaw left forward to minus 45 direction and 450 speed. Drag the jog right forward to 45 direction and 450 speed. Drag the jaw left to minus 90 direction and 300 speed. Drag the jaw right to 90 direction and 300 speed. Drag the jaw left back to minus 135 direction and 300 speed. Drag the jaw right back to 135 direction and 300 speed. Drag the jaw back to 180 direction and 300 speed. Drag the jaw back to minus 180 direction and 300 speed. Drag the run forward to 0 direction and 600 speed. Drag the run left forward to minus 45 direction and 600 speed. Drag the run right forward to 45 direction and 600 speed. Drag the run left forward to minus 45 direction and 300 speed. Right-click to set the animation playback rate to 70% of the original. This way, the animations that move forward to the left can be connected. Drag the drone right forward to 55 direction and 300 speed. Right-click to set the animation playback rate to 70% of the original. This way, the animations that move forward to the right can be connected. Drag in the armed idle animation sequence at all speeds of 0. This completes the setup of the armed standby moving blank space. That is for this lesson. Hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is crouching and moving while armed. Right-click in the blank space order. Select blank space. Select female. Name it BS Reef Crouch. Open. The horizontal axis represents the character's direction, named direction. The minimum value of the direction is minus 180 degrees. The maximum value of the direction is 180 degrees. The number of grid divisions is 8. The vertical axis represents the character's movement speed and is named speed. Here, it is divided into maximum movement speed and minimum movement speed. Set the maximum value to 476. The minimum speed is set to 0. The character's speed is 0 when the character is idle. The number of grids is 8. Next, add an animation sequence to the blank space. Enter Reef Crouch. Drag the idle to 0 direction and 0 speed. Drag the work forward to 0 direction and 150 speed. Drag the work left forward to minus 45 direction and 150 speed. Drag the work right forward to 45 direction and 150 speed. Drag the work left to minus 90 direction and 150 speed. Drag the work right to 90 direction and 150 speed. Drag the work left back to minus 135 direction and 150 speed. Drag the work right back to 135 direction and 150 speed. Drag the work back to 180 direction and 150 speed. Drag the work back to minus 180 direction and 150 speed. Drag the jog forward to 0 direction and 297 speed. Drag the jaw left forward to minus 45 direction and 297 speed. Drag the jog right forward to 45 direction and 297 speed. Drag the jaw left to minus 90 direction and 230 speed. Drag the jaw right to 90 direction and 230 speed. Drag the jaw left back to minus 135 direction and 230 speed. Drag the jaw right back to 135 direction and 230 speed. Drag the jaw back to 180 direction and 230 speed. Drag the run forward to 0 direction and 460 speed. Drag the run left forward to minus 45 direction and 460 speed. Drag the run right forward to 45 direction and 460 speed. Drag in the idle animation sequence at O space of 0. Our animations, jogging and running animation rate are on the fast side, and we need to slow down the animation rate. The best way to do this is to open the original FBX file of the animation and adjust the animation in the 3D modeling software. Here, we do it by adjusting the rate scale. Adjust the animation rate for the 3 animation directions of the run to 0.8. Adjust the animation rate for the 3 forward directions of the jog to 0.7. Adjust the animation rate for the other direction of the jog to 0.6. This completes the setup of the armed cross to move blank space. That is for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is prone and moving while armed. Right-click in the blank space order. Select blank space. Select female. Name it BS Reef Brown. Open. The horizontal axis represents the character's direction, named direction. The minimum value of the direction is minus 180 degrees. The maximum value of the direction is 180 degrees. The number of grid divisions is 8. The vertical axis represents the character's movement speed and is named speed. Here, it is divided into maximum movement speed and minimum movement speed. Set the maximum value to 110. The minimum speed is set to 0. The number of grids is 8. Next, add an animation sequence to the blank space. Drag the idle to 0 direction and 0 speed. Drag the work forward to 0 direction and 110 speed. Drag the work left forward to minus 45 direction and 110 speed. Drag the work right forward to 45 direction and 110 speed. Drag the work left to minus 90 direction and 82 speed. Drag the work right to 90 direction and 82 speed. Drag the work right back to 135 direction and 82 speed. Drag the work left back to minus 135 direction and 82 speed. Drag the work back to 180 direction and 82 speed. Drag the work back to minus 180 direction and 82 speed. These are normal speed animations. When the character is moving, pressing the Ctrl key will reduce movement speed. We also use this animation, implemented in a way that adjusts the animation rate. Drag the work forward to 0 direction and 41 speed. Right-click, set the animation playback rate to 36% of the original. Since the character moves at 36% of normal speed when the Ctrl key is pressed, it's set to 0.36 here. Drag the work left forward to minus 45 direction and 41 speed. Right-click, set the animation playback rate to 36% of the original. Drag the work right forward to 45 direction and 41 speed. Right-click, set the animation playback rate to 36% of the original. Drag the work left to minus 90 direction and 27 speed. Right-click, set the animation playback rate to 28% of the original. Drag the work right to 90 direction and 27 speed. Right-click, set the animation playback rate to 28% of the original. Drag the work left back to minus 135 direction and 27 speed. Right-click, set the animation playback rate to 28% of the original. Drag the work right back to 135 direction and 27 speed. Right-click, set the animation playback rate to 28% of the original. Drag the work back to 180 direction and 27 speed. Right-click, set the animation playback rate to 28% of the original. Drag the work back to minus 180 direction and 27 speed. Right-click, set the animation playback rate to 28% of the original. Drag the work left forward to minus 45 direction and 82 speed. Right-click, set the animation playback rate to 80% of the original. Drag the work forward to 0 direction and 82 speed. Right-click, set the animation playback rate to 80% of the original. Drag the work right forward to 45 direction and 82 speed. Right-click, set the animation playback rate to 80% of the original. This completes the setup of the armed prone to move blank space. That is for this lesson. Thanks for. Hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is standing, aiming, and moving while unarmed. Right-click in the character folder, select blank space. Select female. Name it BS Reef Stand Aim. Open. The horizontal axis represents the character's direction, named direction. The minimum value of the direction is minus 180 degrees. The maximum value of the direction is 180 degrees. The number of grid divisions is 8. The vertical axis represents the character's movement speed and is named speed. Here, it is divided into maximum movement speed and minimum movement speed. Set the maximum value to 180. This indicates that the character's maximum movement speed is 180 centimeters per second. The minimum speed is set to 0. The character's speed is 0 when the character is idle. The number of grids is 6. Next, add an animation sequence to the blank space. Enter Reef Aim Stand. Show all animations that are armed and are in a stand aiming position. Drag the idle to 0 direction and 0 speed. Drag the work forward to 0 direction and 180 speed. Drag the work left forward to minus 45 direction and 180 speed. Drag the work right forward to 45 direction and 180 speed. Drag the work left to minus 90 direction and 150 speed. Drag the work right to 90 direction and 150 speed. Drag the work left back to minus 135 direction and 150 speed. Drag the work right back to 135 direction and 150 speed. Drag the work back to 180 direction and 150 speed. Drag the work back to minus 180 direction and 150 speed. Drag the work forward to 0 direction and 90 speed. Adjust the rate scale to 0.5. Drag the work left forward to minus 45 direction and 60 speed. Adjust the rate scale 0.33. Drag the work left forward to minus 45 direction and 120 speed. Adjust the rate scale 0.66. Drag the work right forward to 45 direction and 60 speed. Adjust the rate scale 0.33. Drag the work right forward to 45 direction and 120 speed. Adjust the rate scale 0.66. Drag the work left to minus 90 direction and 30 speed. Adjust the rate scale 0.2. Drag the work left to minus 90 direction and 90 speed. Adjust the rate scale 0.6. Drag the work right to 90 direction and 30 speed. Adjust the rate scale 0.2. Drag the work right to 90 direction and 90 speed. Adjust the rate scale 0.6. Drag the work left back to minus 135 direction and 90 speed. Adjust the rate scale 0.6. Drag the work right back to 135 direction and 90 speed. Adjust the rate scale 0.6. Drag in the armed idle animation sequence at all speeds of 0. This completes the setting for standing with aiming to move in blank space. That is for this lesson. Thanks for watching. And hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is crouch aiming and moving while armed. Right-click in the character folder, select blank space. Select female. Name it BS Reef Crouch Aim. Open. The horizontal axis represents the character's direction, named direction. The minimum value of the direction is minus 180 degrees. The maximum value of the direction is 180 degrees. The number of grid divisions is 8. The vertical axis represents the character's movement speed and is named speed. Here, it is divided into maximum movement speed and minimum movement speed. Set the maximum value to 138. This indicates that the character's maximum movement speed is 138 centimeters per second. The minimum speed is set to 0. The character's speed is 0 when the character is idle. The number of grids is 6. Next, add an animation sequence to the blank space. Enter Reef Aim Crouch. Drag the idle to 0 direction and 0 speed. Drag the work forward to 0 direction and 138 speed. Drag the work left forward to minus 45 direction and 138 speed. Drag the work right forward to 45 direction and 138 speed. Drag the work left to minus 90 direction and 92 speed. Drag the work right to 90 direction and 92 speed. Drag the work left back to minus 135 direction and 92 speed. Drag the work right back to 135 direction and 92 speed. Drag the work back to 180 direction and 92 speed. Drag the work back to minus 180 direction and 92 speed. Drag in the idle animation sequence at all speeds of 0. Drag the work forward to 0 direction and 23 speed. Adjust the rate scale to 0.16. Drag the work forward to 0 direction and 92 speed. Adjust the rate scale to 0.66. Drag the work left forward to minus 45 direction and 23 speed. Adjust the rate scale to 0.16. Drag the work left forward to minus 45 direction and 92 speed. Adjust the rate scale to 0.66. Drag the work right forward to 45 direction and 23 speed. Adjust the rate scale to 0.16. Drag the work right forward to 45 direction and 92 speed. Adjust the rate scale to 0.66. Drag the work left to minus 90 direction and 23 speed. Adjust the rate scale to 0.16. Drag the work left to minus 90 direction and 69 speed. Adjust the rate scale to 0.6. Drag the work right to 90 direction and 69 speed. Adjust the rate scale to 0.6. Drag the work left back to minus 135 direction and 23 speed. Adjust the rate scale to 0.16. Drag the work left back to minus 135 direction and 23 speed. Adjust the rate scale to 0.6. Drag the work right back to 135 direction and 23 speed. Adjust the rate scale to 0.16. Drag the work right back to 135 direction and 69 speed. Adjust the rate scale to 0.6. Drag the work back to 180 direction and 23 speed. Adjust the rate scale to 0.16. Drag the work back to minus 180 direction and 23 speed. Adjust the rate scale to 0.16. This completes the setting for crouch with aiming to move in blank space. That is for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. This lesson creates animated blank space where the character is skydive. Right-click in the character folder, select blank space. Select female. Name it BS Skydive. Open. The horizontal axis represents the character's lateral velocity. Name it send with velocity. The minimum value of the lateral velocity is minus 3000 degrees. The maximum value of the lateral velocity is 3000 degrees. The number of grid divisions is 8. The vertical axis is used to represent the speed at which the character moves forward. Name it forward value. Set the maximum value to 100. If there is no action after the character jumps, the character will fall, and there will be no movement in the forward direction. The number of grids is 4. Next, add an animation sequence to the blank space. Enter air. Drag the free falling to send with velocity and 0 forward value. Drag the speed up left to minus 1500 send with velocity and 0 forward value. Drag the speed up right to 1500 send with velocity and 0 forward value. Drag the speed up to 0 send with velocity and 100 forward value. This completes the setting for skydive in blank space. That is for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. This session creates features related to aim offset for character animation. This lesson will first look at what aim offset. Aim offset are made in a very similar way to how they are made in blank space. Right-click. Select animation. Aiming offset are also divided into 1 and 2 dimensions. Select 2 dimensions aiming of sight. Select female. Open. The editing interface for aim of sight is almost identical to that of blank space. The horizontal axis represents the rotation value of the character's z-axis. Name it Yao. Set the minimum value to -90. Set the maximum value to 90. The number of grid divisions is 4. The vertical axis represents the x-axis rotation value of the character. Name it Peach. Set the minimum value to -90. The maximum value is set to 90. The number of grid divisions is 4. Set the preview pause to be a gun standby animation sequence. The final rendering of the aim of sight is fused with other animations, so the preview animation selected here is fused. Enter normal stand aim of sight. Drag the center to the 0, 0 position. Drag the D animation to position 0, -90. Drag the green dot. Like the blank space, the aim of sight can be used to control the animation's final performance numerically. Remove the text aim of sight. That's it for this lesson. Thanks for watching and we'll Hello everyone, I'm Big Cat. In this lesson, we're going to create an unarmed standing aim of sight. Create a folder in the character folder. Name it aim of sight. All of sight files are placed in this folder. Right-click, select aim of sight in animation. Select female. Name it aim of sight normal stand. Open. The horizontal axis represents the rotation value of the character's z-axis. Name it Yao. Set the minimum value to -90. It indicates that the maximum value of the character's turn to the left is 90 degrees. Set the maximum value to 90. It indicates that the maximum value of the character's right turn is 90 degrees. The number of grid divisions is 4. The vertical axis represents the x-axis rotation value of the character. Name it Peach. Set the minimum value to -90. It indicates that the maximum value of the character's downward turn is 90 degrees. The maximum value is set to 90. It indicates that the maximum value for the character's upward turn is 90 degrees. The number of grid divisions is 4. Set the preview base pause. Next, we start adding animations to the graph. Enter normal stand aim of sight. Drag the center animation to position 0, 0. Drag the look up animation to position 0, 90. Drag the look down animation to position 0, -90. Drag the look left animation to position -90, 0. Drag the look right animation to position 90, 0. Drag the look left up animation to position -45, 45. Drag the look right up animation to position 45, 45. Drag the look left down animation to position -45, -45. Drag the look right down animation to position 45, -45. Preview the effect by dragging the grid dots with the mouse. This completes the setting of the unarmed standing aim of sight. That's it for this lesson. Thanks for watching, and we'll see you. Hello everyone, I'm Big Cat. In this lesson, we're going to create an unarmed crouch aim offsight. Right-click, select aim offsight in animation. Select female. Name it aim offsight normal crouch. Open. The horizontal axis represents the rotation value of the character's z-axis. Name it Yao. Set the minimum value to -90. It indicates that the maximum value of the character's turn to the left is 90 degrees. Set the maximum value to 90. It indicates that the maximum value of the character's right turn is 90 degrees. The number of grid divisions is 4. The vertical axis represents the x-axis rotation value of the character. Name it Peach. Set the minimum value to -90. It indicates that the maximum value of the character's downward turn is 90 degrees. The maximum value is set to 90. It indicates that the maximum value for the character's upward turn is 90 degrees. The number of grid divisions is 4. Set the profile base pose. Next, we start adding animations to the graph. Enter normal crouch, aim offsight. Drag the center animation to position 0, 0. Drag the look up animation to position 0, 90. Drag the look down animation to position 0, -90. Drag the look left animation to position -90, 0. Drag the look right animation to position 90, 0. Drag the look left up animation to position -45, 45. Drag the look right up animation to position 45, 45. Drag the look left down animation to position -45, -45. Drag the look right down animation to position 45, -45. Prevail the effect by dragging the grid dots with the mouse. This completes the setting of the unarmed crouch aim offsight. That's it for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. In this lesson, we're going to create an armed standing aim offsight. Right-click, select aim offsight in animation. Select female. Name it aim offsight reef stand. Open. The horizontal axis represents the rotation value of the character's z-axis. Name it Yao. Set the minimum value to -90. It indicates that the maximum value of the character's turn to the left is 90 degrees. Set the maximum value to 90. It indicates that the maximum value of the character's right turn is 90 degrees. The number of grid divisions is 4. The vertical axis represents the x-axis rotation value of the character. Name it Peach. Set the minimum value to -90. It indicates that the maximum value of the character's downward turn is 90 degrees. The maximum value is set to 90. It indicates that the maximum value for the character's upward turn is 90 degrees. The number of grid divisions is 4. Set the profile base pose. Next, we start adding animations to the graph. Enter reef stand, aim offsight. Drag the center animation to position 0, 0. Drag the look up animation to position 0, 90. Drag the look down animation to position 0, minus 90. Drag the look left animation to position minus 90, 0. Drag the look right animation to position 90, 0. Drag the look left up animation to position minus 45, 45. Drag the look right up animation to position 45, 45. Drag the look left down animation to position minus 45, minus 45. Drag the look right down animation to position 45, minus 45. Prevail the effect by dragging the grid dots with the mouse. This completes the setting of the armed standing aim of sight. That's it for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. In this lesson, we're going to create an armed aiming standing aim of sight. Right-click, select aim of sight in animation. Select female. Name it aim of sight ref aim stand. Open. The horizontal axis represents the rotation value of the character's z-axis. Name it Yao. Set the minimum value to minus 90. It indicates that the maximum value of the character's turn to the left is 90 degrees. Set the maximum value to 90. It indicates that the maximum value of the character's right turn is 90 degrees. The number of grid divisions is 4. The vertical axis represents the x-axis rotation value of the character. Name it Peach. Set the minimum value to minus 90. It indicates that the maximum value of the character's downward turn is 90 degrees. The maximum value is set to 90. It indicates that the maximum value for the character's upward turn is 90 degrees. The number of grid divisions is 4. Set the prevail base pose. Next, we start adding animations to the graph. Enter ref aim stand, aim of sight. Drag the center animation to position 0, 0. Drag the look up 45 degrees animation to position 0, 45. Drag the look up 90 degrees animation to position 0, 90. Drag the look down 45 degrees animation to position 0, minus 45. Drag the look down 90 degrees animation to position 0, minus 90. Drag the look left 45 degrees animation to position minus 45, 0. Drag the look left 90 degrees animation to position minus 90, 0. Drag the look right 45 degrees animation to position 45, 0. Drag the look right 90 degrees animation to position 90, 0. Drag the look left up animation to position minus 45, 45. Drag the look right up animation to position 45, 45. Drag the look left down animation to position minus 45, minus 45. Drag the look right down animation to position 45, minus 45. Prevail the effect by dragging the grid dots with the mouse. This completes the setting of the armed standing aim of sight. This completes the setting of the armed aiming standing aim of sight. That's it for this lesson. Thanks for watching, and we'll see you. Hello everyone, I'm Big Cat. In this lesson, we're going to create an armed crouch aim of sight. Right-click, select aim of sight in animation. Select female. Name it aim of sight rev crouch. Open. The horizontal axis represents the rotation value of the character's z-axis. Name it Yao. Set the minimum value to -90. It indicates that the maximum value of the character's turn to the left is 90 degrees. Set the maximum value to 90. It indicates that the maximum value of the character's right turn is 90 degrees. The number of grid divisions is 4. The vertical axis represents the x-axis rotation value of the character. Name it pitch. Set the minimum value to -90. It indicates that the maximum value of the character's downward turn is 90 degrees. The maximum value is set to 90. It indicates that the maximum value for the character's upward turn is 90 degrees. The number of grid divisions is 4. Set the profile base pose. Next, we start adding animations to the graph. Enter rev crouch aim of sight. Drag the center animation to position 0, 0. Drag the look up animation to position 0, 90. Drag the look down animation to position 0, -90. Drag the look left animation to position -90, 0. Drag the look right animation to position 90, 0. Drag the look left up animation to position -45, 45. Drag the look right up animation to position 45, 45. Drag the look left down animation to position -45, -45. Drag the look right down animation to position 45, -45. Prevail the effect by dragging the grid dots with the mouse. This completes the setting of the armed crouch aim of sight. That's it for this lesson. Thanks for watching, and we'll see you next session. Hello everyone, I'm Big Cat. In this lesson, we're going to create an armed aiming crouch aim of sight. Right-click, select aim of sight in animation. Select female. Name it aim of sight rev aim stand. Open. The horizontal axis represents the rotation value of the character's z-axis. Name it Yao. Set the minimum value to -90. It indicates that the maximum value of the character's turn to the left is 90 degrees. Set the maximum value to 90. It indicates that the maximum value of the character's right turn is 90 degrees. The number of grid divisions is 4. The vertical axis represents the x-axis rotation value of the character. Name it pitch. Set the minimum value to -90. It indicates that the maximum value of the character's downward turn is 90 degrees. The maximum value is set to 90. It indicates that the maximum value for the character's upward turn is 90 degrees. The number of grid divisions is 4. Set the profile base pose. Next, we start adding animations to the graph. Enter rev aim crouch aim. Drag the center animation to position 0, 0. Drag the look up animation to position 0, 90. Drag the look down animation to position 0, -90. Drag the look left animation to position -90, 0. Drag the look right animation to position 90, 0. Drag the look left up animation to position -45, 45. Drag the look right up animation to position 45, 45. Drag the look left down animation to position -45, -45. Drag the look right down animation to position 45 minus 45. Prevail the effect by dragging the grid dots with the mouse. This completes the setting of the armed aiming crouch aim of sight. That's it for this lesson. Thanks. Hello everyone, I'm Big Cat. In this session, we are going to work together to create an animation blueprint for our character. In this lesson, we'll start by learning what an animation blueprint is. Let's start by creating an animation blueprint. Right-click on the character folder and select Animation Blueprint. Select Female Skeleton. Name it My Anime Blueprint. Open. There are three most important parts of the animation blueprint. One is the current defined open aim graph. The aim graph is used to evaluate the skeletal mesh body's final pose for the current frame. Here we can blend the animation, and we can also directly modify the skeletal position, scaling, and zooming. Click to go to Event Graph. This is Event Graph. There is a different event here called Event Blueprint Update Animation. This event is executed every frame. In this event, you can update the character state in real time, such as the character current movement speed, direction, and so on. There is also a very important part, the state machine. Open the aim graph. Right-click the mouse. Enter Add State. Select Add State Machine. You can see that an animation state machine is created. In the state machine, different animations are displayed by the current state. In the next lesson, we'll refine the state machine in more detail. Summarize animation blueprint. In the animation blueprint, by updating the character state data in the event graph. This data is used in the animation graph and presents the character current frame animation. In this lesson, we've both learned what an animation blueprint is, and we'll continue to learn how to use animation blueprint in more depth in the future. That's it for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, we'll create character state variables in Animation Blueprint. Open my Anime Blueprint. Create a variable's name is speed. Type is float, used to indicate the speed at which the character moves on the ground. The unit is centimeter per second. Note that this speed value only represents the speed at which the character moves on the ground. This value will control the velocity value in the blank space made in the previous class. Create a variable, name it direction. Type is float. It is used to indicate the direction of the character on the ground. Note that this orientation value we will control between minus 180 degrees and 180 degrees. This value will control the direction value in the blank space made in the previous class. Create a variable, name it pitch. Type float. It is used to represent the value of the character rotation in the x-axis direction. Create a variable, name it yaw. Type is float. It is used to represent the character rotation in the y-axis direction. In previous lessons, we create aim of sight animation, and these two values control the aim of sight animation. Create a variable, name it forward value. Type is float. This value is not some kit of rate speed of the character. Its purpose is to control the character pitch angle while in the air. Create a variable, name it sideways velocity. The type is float. It is used to represent the lateral movement speed of the character while in the air. Create a variable, name it is jumping. Type is boolean. It is used to indicate if the character is currently in a jump state or not. Create a variable, name it is crouching. Type is boolean. It is used to indicate whenever the character is currently crouching or not. Create a variable, name it is prone. Tab is boolean. It is used to indicate if the character is currently prone. Create a variable. Name it is in air. Tab is boolean. It is used to indicate whether the character is currently jumping or falling from some height. This variable does not indicate and does not affect the character state in the air after jumping. Create a variable. Name it is hold weapon. Tab is boolean. Indicates if the character is currently armed. Note that it is holding a gun. Create a variable. Name is aim. It is used to indicate whether or not the character is currently in a gun aim state. Create a variable. Name it is free falling. Tab is boolean. It is used to indicate if the character is in free fall. Create a variable. Name it is umbrella opened. Tab is boolean. It is used to indicate if the character has opened the parachute. Create a variable named is dead. Tab is boolean. It is used to indicate if the character is currently dead. The variables are created here first. These variables will work together to control the character animation in each frame. That's it for this lesson. Thanks. Hello everyone, I'm Big Cat. Starting with this lesson, we are going to perfect the state machine. This lesson refers the animation associated with the character in the unarmed state. Open the MN graph in my MN blueprint. Rename the state machine we created in the previous lesson to local motion. Connect the state machine to the output port. Compile. After compiling, a warning will appear warning as that this is an empty state machine. Double-click to open the state machine. Enter BS underline in the resource search field. Drag into the normal stand blank space. Double-click. Set the direction and speed. Connect the entry to the normal stand. Compile. After compiling is complete, you can see the character begin to perform the normal stand animation. Return to the state machine. Click on the Animation Preview Edit panel. All the variables can be set in this panel to see changes in the character action state without running the game. Set the speed to 160. You can see the character starts to play the working animation based on the speed value. Set the direction to -90. You can see that the character modifies the direction based on the direction value. So during the process of making our state machine, we can test the state machine for problems in this way. Revert the speed value and the direction value. Next, we make from standing to crouching. Drag in the normal crouch. Double-click. Set direction and speed values. Connect the normal stand to normal crouch. We can see that there's an icon here, and this icon means execute conditions. Double-click on the icon, and we see that we have entered the rule from normal stand to normal crouch. Drag into the is crouching variable. Connect. Go back to the state machine. Click on the Animation Preview Edit panel. Compile. Set the crouch to true. You can see that the animation now performs to the crouch position. Connect normal crouch to normal stand. Double-click to enter the rule edit. From crouch to stand, you need to determine when the crouch is false. Compile. Uncheck the begin crouched state. You can see that the character changes to a standing position. Next, Create the standing to prone animation. Drag into the normal prone blank space. Double-click. Set the direction and speed values. Transition animations are needed, whether you are going from standing to prone or from crouching to prone. Search for the transition animation from stand to prone. Drag in the normal stand to prone. Remove the AS to save space. Connect the normal stand to transition animation. Double-click. To go from standing to prone, determine when pause is true. Connect the transition animation to the prone blank space. Double-click. Here, you need to determine when the transition is finished and start playing the prone blank space. Use the time remaining node. This node returns the number of seconds left until the end of the animation. When the time is less than or equal to 0.3 seconds, the animation is considered to have finished playing. Compile. Back to the state machine. In the Animation Preview Edit panel, set the prone state to true. You can see that the character has executed the transition from standing to prone first. When the transition animation is finished, the prone blank space is executed. Drag into the normal prone to stand animation. Remove the AS. Connect the prone blank space to the transition animation. Double-click. To go from prone to standing up, you need to determine when the prone is false. Connect the transition animation to the standing blank space. Double-click. The rule is executed when 0.3 seconds remaining in the animation. Compile. Set the prone state to false. You can see that the character first executed the transition from prone to standing. Search for the transition animation from crouch to prone. Drag in the transition animation from crouching to prone. Remove the AS to save space. Connect the normal crouch to transition animation. Double-click. From standing to prone, determine when the prone is true. Connect the transition animation to the prone blank space. Double-click. Execute when 0.3 seconds remaining in the animation. Return to the state machine interface. Compile. Set the crouch state to true. Set the prone to true. You can see that the character has executed the transition from crouch to prone first. Drag into the normal prone to crouch animation. Remove the AS. Connect the prone blank space to the transition animation. Double-click. To go from prone to standing, we need to determine when the prone is false. since this uses the same pawn blank space as the stand to pawn. You need to determine the current crouching state here. Open the pawn to stand rule. Here, we need to add a rule to determine that we are not currently crossing. Connect the transition animation to the crouch blank space. Double-click. Execute the rule when there are 0.3 seconds left in the animation. Compile. Set the crouch state to true. Set the pawn state to true. Set the pawn state to false. You can see that the character first performs the transition from pawn to crouching, and then performs the crouching blank space when the transition animation is finished. Right-click. Select Add Comment. Reset the comment box. In this lesson, we created the animation treatment related to the character in the unarmed state. That is for this lesson. Thanks for watching. And hello everyone, I'm Big Cat. In this lesson, we're going to create animations of character with guns in their hands. Enter BS underline in the resource search field. Drag into the ref stand blank space. Double-click. Set direction and speed. Connecting the normal stand to ref stand. Double-click. To go from unarmed to armed, you need to determine the armed status to be true. Compile. Back to the state machine. Set the gun status to true. You can see that the character is on gun standby. Connecting the ref stand to normal stand. Double-click. From armed to unarmed, you need to determine the armed status as false. Compile. Back to the state machine. Set the gun status to true. Set the gun status to false. You can see the character has gone to unarmed standby. Next, we'll create standing to crouching position. Drag into ref crouch. Connecting ref stand to ref crouch. Double-click. From ref stand to ref crouch, you need to determine the crouch status as true. Back to the state machine. Compile. Set the gun status to true. Set crouch to true. You can see the animation is now crouching with a gun. Connect ref crouch to ref stand. Double-click to enter rule edit. From crouching to standing, you need to determine when the crouching is false. Back to the state machine. Compile. Set the gun status to true. Set crouch to true. Set crouching to false. You can see the character has changed to a standing position with a gun. Next, we are going to go from a standing position to a prone position. Drag into ref stand to prone. Remove the AS. Connecting riff stand to transition animations. Double-click. From standing to transition animation, determine when prone is true. Drag into riff prone. Set direction and speed values. Connecting transition animations to riff prone. Double-click. Execute when 0.3 seconds remaining in the animation. Compile. Set the gun status to true. Set the prone status to true. In the preview window and state machine interface, you can see that the character first executes the transition animation from standing to the prone position, and then executes the blank space from the prone position after the transition animation is finished. Drag into riff prone to stand. Remove the AS. Connecting the pawn to the translation animation. Double-click. From standing to translation animation, we need to determine when the pawn position is false. Connecting transition animations to standing. Double-click. Execute when 0.3 seconds remaining in the animation. Compile. Set hold gun status to true. Set the pawn to true. Set the pawn to false. You can see the character animation go from prone with a gun to standing up with a gun. Next, we'll create a crouch to a pawn. Search translation animations. Drag into riff crouch to pawn. Remove the AS. Connecting riff crouch to transition animation. Double-click. From crouch to transition animation, you need to determine when the pawn is true. Connecting transition animation to riff pawn. Double-click. Execute when 0.3 seconds remaining in the animation. Back to the state machine interface. Compile. Set the hold gun status to true. Set the crouch status to true. Set the pawn status to true. You can see that the character first executes the transition animation from a crouch to pawn, and then executes the pawn blank space after the transition animation is finished. Drag into riff pawn to crouch. Remove the AS. Connecting the pawn to the transition animation. Double-click. From standing to transition animation, we need to determine when the pawn is false. Since we are using the same blank space as standing to pawn, we need to determine that we are currently crouching. Likewise, the transition from a pawn blank space to a stand animation needs to be determined not to be crouched. Connect the transition animation to rev crouch. Double-click. Execute the rule when there are 0.3 seconds left in the animation. Compile. Set hold gun to true. Set crouch to true. Set prone to true. Set prone to false. You can see how the character animations from hold gun prone to hold gun crouch. Right-click, select Add Comment. In this lesson, we have animated the character in the hold gun related state. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we'll connect armed and unarmed animations. Connecting normal crouch to a rev crouch. Double-click. To go from unarmed to armed, you need to determine the armed status to be true. Connecting rev crouch to normal crouch. Double-click. From armed to unarmed, you need to determine the armed status as false. Compile. Back to the state machine. Set the crouch to true. Set hold gun status to true. You can see the character has changed from an unarmed crouch to a hold gun crouch. Set the hold gun status to false. You can see that the character has changed from a hold gun crouch to an unarmed crouch. Next, we are going to make a no gun prone to a hold gun prone. Connecting normal prone to rev prone. Double-click. To go from unarmed to armed, you need to determine the hold gun status to true. Connecting rev prone to normal prone. Double-click. From armed to unarmed, you need to determine the hold gun status as false. Compile. Back to the state machine. Set the prone to true. Set hold gun status to true. You can see the character has changed from a no gun prone to a hold gun prone. Set the hold gun status to false. You can see that the character has changed from armed prone to unarmed prone. That is for this lesson. Thanks for watching. And we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to create an animation about aiming and hold gun. Drag into rev crouch, aim. Double-click, set direction and speed values. Connect crouch aim to crouch. Double-click. From aiming to unaiming, you need to determine the aiming status as false. Connect crouch to crouch aim. Double-click. From unaimed to aim, you need to determine the aiming state to be true. Back to the state machine. Set the crouch to true. Set hold gun status to true. Set aiming to true. You can see the character change from unaimed to aim. Drag into ref stand aim. Connecting standing aim to standing. Double-click. From aiming to unaiming, you need to determine the aiming status as false. Connecting stand to stand aiming. Double-click. From unaimed to aim, you need to determine the aiming state to be true. Set hold gun status to true. Set aiming to true. You can see the character change from unaimed to aim. Connect standing aim to crossing aim. Double-click. From standing to crossing, you need to determine the crossing state to be true. Connect crouch aim to stand aim. Double-click. From crossing to standing, you need to determine that the crossing state is false. Compare. Back to the state machine. Set hold gun status to true. Set aiming to true. Set crouch status to true. You can see the character change from standing aim to crossing aim. Set crossing status to false. You can see the character change from crossing aim to standing aim. Neither the aiming stance or the crossing stance needs to be connected to the prone state. If the character performs the prone action in the aiming form, it will first change the character aiming state to false before completing the transition animation to the prone state. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to create character skydive related animations. Drag into the skydive blank space. Double-click. Set the lateral speed and forward speed. Connecting normal stand to skydive. Double-click. From unarmed standing to parachuting, you need to determine that you are true both in the air and in free fall. Set both in air and free fall states to true. You can see the character go from standing unarmed to free falling. Drag into open the parachute animation. Delete this AS underline. Connecting the skydive to the open parachute animation. Double-click. From the free fall to parachute opening, you need to determine the parachute opening status to be true. Drag into the open parachute animation. Delete the AS underline. Connecting the parachute opening animation to the free animation. Double-click. Execute when 0.3 seconds remaining in the animation. Compile. Back to the state machine. Set both in air and free fall to true. Set open parachute to true. You can see the character change from free fall to open parachute animation, and when the open parachute animation plays, the free parachute animation plays. Drag into to ground animation. Delete the AS underline. Connecting free animation to ground animation. Double-click. You need to determine the in the air status from free fall to ground animation to be false. Connecting to ground animation to unarmed standing animation. Double click. Execute when 0.3 seconds remaining in the animation. Compile back to the state machine. Set in-air freefall open parachute to true. Set the in-air state to false. You can see the character change from free animation to ground animation and finally to unarmed standby animation. Adding comments. That's it for this. Hello everyone, I'm Big Cat. In this lesson, we are going to create an animation about character jumping. Drag into the stand jump start. Delete the AS underline. Connect normal stand to start jumping. Double click. From standing unarmed to starting to jump, you need to determine in the air status to be true. Drag into the stand jump loop animation. Delete the AS underline. The connection starts to the jump loop. Double click. Execute when 0.3 seconds remaining in the animation. Drag into the stand jump end animation. Delete the AS underline. Connect the jump loop to the jump end. Double click. From standing unarmed to starting to jump, you need to determine the in the air status to be false. Connect jump end to unarmed standby. Double click. When the animation has 0.3 seconds remaining. And hold gun is false. Compile. Set the in-air status to true. You can see the character jumping up. Set the in-air status to false. You can see the character on the ground. Adding comments. Next, make a hold gun jump. Connect the hold gun stand to start jumping. Double click. From standing with a gun to starting to jump, you need to determine the in the air status to be true. Connect jump end to hold gun stand. Double-click when the animation has 0.3 seconds remaining. And hold gun is true. Compile. Set the hold gun and in the air states to true. You can see the character jumping up. Set in-air status to false. You can see the character on the ground. Use the jump loop to connect the sky dial. Double-click. Set is free fall. Compile, save. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to create character death-related animations. Drag in stand to death animation. Delete the AS underline. Connecting unarmed stand to death animation. Double-click. From standing to dead, you need to determine the dead state to be true. Connecting hold gun stand to death animation. Double-click. From standing to dead, you need to determine the dead state to be true. Set the death state to true. You can see the character death animation playing, but we found that we keep looping the death animation. This is not the result we want. We want the death animation to play only once. Double-click. Select animation. Uncheck loop play in the details panel. Compile. Set the death state to true. You can see that now the death animation doesn't loop after it finishes playing. Compile. Set the gun status and the death status to true. The character plays correctly from a hold gun state to a dead state. Drag in crouch death animation. Delete the AS underline. Connect unarmed crouch to death animation. From crouching to dead, you need to determine the dead state to be true. Connect hold gun crouch to death animation. Double-click. From crouching to dead, you need to determine the dead state to be true. Set the death state to true. You can see the character death animation playing. Set the crouch death animation loop to false. Compile. That's it for this lesson. Thanks for watching and hello everyone, I'm Big Cat. In this lesson, we're going to make an animated graph about it. A setting was left out when making the functions related to state machine gun holding. So let's catch up. First, double-click rev crouch. Set direction and speed. Double-click rev stand aim. Set direction and speed. Double-click. First, in the animation graph, the output pulse node is the final animated form of the character. We can see that the line from the state machine to the final morph keeps scrolling, which means that the animation graph calculates the morph of the character's animation at every frame. In the animation graph, the main blending of the character's animations is done. First, we'll blend the base animations with the montage animations. Disconnecting the state machine. Drag the state machine and enter the cache. Create a cache for the state machine. Name it local cache. Click on the window menu and select the animation slot manager. In the bottom right corner of the editor, you can see that the animation slot management panel is already open. In this panel, you can create groups and create new slots. Create a slot. Name it upper body. We use this slot for all of our future montage animations. Montage animations include character shooting animations, weapon changing animations, and clip changing animations. These animations only need to blend the character's upper body movements, hence the name upper body. Get the newly created state machine cache. Connect to the slot. Select the slot as upper body in the Details panel. This gives us a blend of the base animation and the montage animation. Create a cache of the blended state. Name it Montage Cache. Adding comments. Next, blend the aim of sight into the character animation. Enter aim of sight. You can see that there are currently 6 states of aiming of sight. Drag these 6 targeting of sights into the graph. Set the yaw and pitch values. Set the base pose to montage catch. Only one of these 6 states will execute at the same time. Adding blend pose by int node. The function of this node is to determine which pose to execute by the index value. Right-click and select Add Blend Pin. There are a total of 6 states and 1 state that does not require a blend of aim of sight, so there is 7 poses in total. Blend time corresponds to each pose above and indicates the time needed to blend this animation. The default is 0.1 seconds, so you don't need to change it. We connect the 7 states in order. We need a variable to represent the current animation state of the character. Create a variable named aimOffset tab. Set the variable tab to integer. Setting variables to nodes. Create a cache of the blended state. Name it aimOffset cache. Add comment. Next, blend the Montage and aimOffset cache into the base animation using layered blend for OM nodes. The function of this node is to blend hierarchically by the skeleton. This blending only affects a small portion of a specific bone in the skeleton. For example, our Montage and aimOffset both affect only the top half of the character, so use this node to blend only the top half. Select this node and open Layer Setup in the Details panel, adding an array of elements. The skeleton name is span01, and the blend depth is 1. Base posture using local cache. Blend poses using montage cache. Before you set the final pose, you need to determine if a montage animation is currently playing. Use the blend poses by balloon node. Add a variable, name it is playing montage. Tap boolean. This indicates if the montage is currently playing. Use the is playing montage variable to determine. If the montage is playing, use the upper body blend. If no montage animation is playing, use the aimOffset animation. Connect the final output. Adding comment. In this lesson, we make an animated graph. This includes blending montage, blending aimOffset, and blending the assigned character upper body. That's it for this. Hello everyone, I'm Big Cat. In this lesson, we will test each of the features related to the graph we created in the previous lesson. Be sure to compare the graph after they are created. At the bottom of the preview window, make sure the character animation is playing. Set the aimOffset tab value to 1. You can see the blended animation of aimOffset starting to preform unarmed stand up. Set the pitch value to 45. You can see the character change to a head-up action. Set the yaw value to 45. You can see the character change to look to the right and up. Set the aimOffset tab value to true. Set the crouch status to true. You can see the aimOffset blending animation that begins to perform the unarmed crouch. Set the pitch value to -45. Set the yaw value to -45. You can see the character change to look the left with a head movement. Set hold gun status to true. Set the aim of sight tab value to 3. You can see the aim of sight blending animation that begins to perform hold gun stand. Set the pitch value to 45. You can see the character change to hand up action. Set the yaw value to -45. You can see the character change to look to the left and up. Set the aim of sight tab value to 4. You can see the blended aim of sight animation that starts to perform the hold gun crouch. Set the pitch value to 35. You can see the character change to a hand up action. Set the yaw value to -45. You can see the character change to look to the left and up. Set hold gun status to true. Set aiming to true. Set the aim of sight tab value to 5. You can see the aim of sight blend animation that starts to perform hold gun to stand. Set the pitch value to 35. Set the yaw value to -45. You can see the character change to look to the left and up. Set crouch to true. Set the aim of sight tab value to 6. You can see the aim of sight blend animation that begins to perform the hold gun aim crouch. Set the pitch value to 35. Set the yaw value to -45. You can see the character change to look the left with a head movement. In this lesson, we tested the aim of sight blending animation, and the Montage-related test will continue to be tested later in the lesson. That's it for this lesson. Thanks for watching, and we'll see you. Hello everyone, I'm Big Cat. In this lesson, we'll begin to create the relevant functions in the event graph. Double-click the event graph. By default, there are 2 nodes in this graph. One is the animation update event. This node acts when the animation is updated. The try-get-pawn owner node is all about getting the current pawn, which in our game is actually getting the current my character. In this event graph, we need to get the current state of the current from my character and set it to a variable in the animation blueprint. Since we need to get the character states in my character, we need to create variables in my character first. Open my character. Add a variable. Named is crouching. Of type boolean. And category character pose. Indicates if the character is in a crossing position. Add a variable. Named is pawn. Of type boolean. And category character pose. Indicates if the character is currently pawn. Add a variable. Named is dead. Of type boolean. And category as character state. It indicates if the current character is dead. Add a variable named is hold weapon. Type boolean and category as character state indicates if the character is currently holding a gun. Add a variable named is aiming. Of type boolean and category character state indicates whenever or not the character is currently aiming. Add a variable named is firing. Type boolean and category character state indicates if the character is currently firing. Add a variable named is equip. Tab Boolean category as character state indicates if the current character is changing weapons. Add a variable named isReload. Tab Boolean and the category as character state indicates if the character is currently changing magazines or bullets. Add a variable named isOnTheAir. Tab Boolean and the category as on the air. It indicates if the character is currently in the air. Add a variable named isFreeFalling. Tab Boolean and the category as on the air indicates if the current character is in free fall. Add a variable named isUmbrellaOpened. Tab Boolean category as on the air. It indicates if the current character has a parachute open. Add a variable named forwardValue. Tab Float and categories on the air indicates the relative value of the pitch angle of the current character. Add a variable named isPlayingMontage. Tab Boolean and categories animation indicates if the montage is currently playing or not. Compile and save. The variables were created here first. This is not all of the variables in my character. They are currently sufficient to support the animation blueprint. That is for this lesson. Hello everyone, I'm Big Cat. Starting in this lesson, we set the variables in the animation blueprint. Some of these variables can be obtained directly from character. In this lesson, we'll start by setting up the variables obtained directly from character. First, we need to get the MyCharacter object. As we talked about in the previous lesson, the trackGetPawnOwner node is used to get the current character. And it should be noted that this node does not necessarily return the object. So you need to determine if the object is returned first. Using the isValue node to decide on the returned value. Convert a pawn tab to a MyCharacter tab using the cast2 node. Right-click the cast2 node and select Convert to pubgcast. Promote transform objects into variables. Name it MyCharacterRef. Make pawn validly connect to MyCharacterRef node. Adding comment. To improve the blueprint's readability, add a sequence node. As many variables will be set. Find out if montage is currently playing or not by MyCharacter, and set it to the animation blueprint. Adding comment. Get the crouch state via MyCharacter. Set the crouch variable to the animation blueprint. Get the pawn state via MyCharacter. Set the pawn variable to the animation blueprint. Adding comments. Get dead status via my character. Set the death state variable to the animation blueprint. Get the gun status via my character. Set the gun status variable to the animation blueprint. Get aiming status via my character. Set the aiming status variable in the animation blueprint. Adding comment. That is for this lesson. Thank you for watching, and I will see you next lesson. Hello everyone, I'm Big Cat. Some variables in the animated graph cannot be obtained directly from character and require some calculations. In this lesson, we'll set up the variables that need to be calculated to get them. The next step is to calculate the speed of the current character. Using the getVelocity node via my character, you can get the vector of your character's current speed. Get velocity values from vector length nodes. Set speed variable to the animation blueprint. Adding comment. Next, calculate the direction value of the current character. Get the calculate direction node. The purpose of this node is to calculate the current direction of the character from the character's speed and the character's rotation, which ranges from -180 to 180. Get the speed value from my character. Get rotation value from my character. Set the direction variable to the animation blueprint. Adding comment. Next, the angle of the current character is calculated. Get the control rotation from my character. Note that this is to get the value of the control rotation. Get the actual rotation from my character. The dot node is used to get the angle of the current character. The character of this node is to normalize. Flip the return value. Set to the pitch and yaw variables in the animation blueprint. Adding comments. That's it for this lesson. Thanks for watching, and we'll see you. Hello everyone, I'm Big Cat. This lesson sets up on air-related variables, as well as calculating the aim of sight type value. Let's start by setting up in the air-related variables. Get the character movement component object first. Call the isFalling node to get if it's in the air or not. Set on-air variables. Set the isFreeFalling variable. Set the isUmbrellaOpened variable. Set forward value variable. The last one is the lateral movement speed of the character in the air. Get the current character speed value. Then reverse it according to the current rotation value. Slip the return value, where the y value is the lateral movement speed we need. Adding comments. In the previous lesson, we set the animation aim offset blend in the animation graph, which has an aim offset type value that controls which animation aim offset blend is currently being used. Next, set the aim offset type value. Determine if they are in the air first. Currently, all of our animated aim offset is based on the character being on the ground. So if the character is in the air, we don't use animated aim offset. Set aim offset type to 0, since we don't have an animated aim offset for pawn. If the character is currently pawn, set aim offset type to 0. Next, determine if the current crouching position is crouching. If it is crouching, we need to determine whenever it is holding a gun. If the gun is held, you need to determine if it's in aiming. If it's an aiming state, it's crouched with the gun aimed. Open the animation graph, and you can see that this state value is 6. Go back to the event graph and set aim offset type to 6. If it's not an aiming state, it's a crouched gun holding state. Open the animation graph, and you can see that this state value is 4. Go back to the event graph and set aim offset type to 4. If it's not armed, then it's crouched and unarmed. Open the animation graph. You can see that the value of this state is 2. Go back to the event graph and set the aimOfSite type to 2. If it is not crouched, it can only be standing state. Need to determine whether it is a hold gun state. If the gun is held, you need to determine if it's in aim condition. If it's an aiming state, it's standing with the gun aimed. Open the animation graph, and you can see that this state value is 5. Go back to the event graph and set aimOfSite type to 5. If it's not the aim state, it's the stand and hold gun state. Go back to the event graph and set the aimOfSite type to 3. If it's not armed, it's standing unarmed. Open the animation graph. You can see that this state value is 1, and set the aimOfSite type to 1. At this point, we have judged all the possibilities of the aimOfSite type value on the end. Compile and save. Adding comments. The job of setting variables in the event graph is now completed. The handling of montage animation events will also be added to the event graph in the future. That's it for this lesson. Thanks for watching, and we'll see you. Hello everyone, I'm Big Cat. From the beginning of the lesson, we're going to create an animation montage related to work. First, let's see how to create an animation montage. There are 2 ways to create an animation montage file. The first way is to right-click on the place where you want to create the file. Click here to select a skeleton and choose a female character skeleton. This creates a montage of files. Double-click to enter the montage editing interface. Animation can be added to the current montage by dragging and dropping animation resources. There is another way to create a montage. Find an animation resource. Right-click on the animation resource where you want to create the montage. Select Create Animation Montage. This will create an animation montage of this animation directly. Double-click to open the file and you can see the animation automatically generated. We can see that there is a default group setting here. The default state is the default slot. When we talked about animation graphs in lesson 39, we created an upper body slot. This should be set to upper body if the current montage is to blend only the character upper body. This way, it will only affect the character upper body animation when playing this animation montage. After changing the default group, the animation stops playing usually. Reopen the file. The animation resumes playing usually. Next, I'll look at how to create sessions for the animation. Right-click and select Create Montage Session. Type the name of the session as S1. That's how we split the animation into 2 parts. The first part is called Default, and the second part is called S1. You can preview the animation of the different sessions by clicking here. When playing an animated montage, you can start playing from a specified position by the session name, and you can also loop the specified session. Event can be sent at a specified location in the montage. Right-click in Notifies and select Add Notification. Then select New Notification. Name it Notify1. This notification is sent when this frame is executed. We can listen to this event in the event graph of the animation blueprint. In this lesson, we have briefly looked at what animation montages are and their essential functions. In later lessons, we'll continue to create animation montages that we'll use in our game. Delete the animation montage file that we just created for testing purposes. That's it for this lesson. Thanks for. Hello everyone, I'm Big Cat. In this lesson, we are going to create an animation montage of an equipped rifle. First, let's create the ending equipped weapon animation montage file. Create a folder in Blueprints, Character. Name it Montage. This folder holds all the animation montage files. Go to the folder, Access, Animations, Humans, Female, Special. Right-click on the AS Stand Equip animation and select Create Animation Montage. Double-click to open the file. Modify slot to upper body. Reopen the file. And the animation displays normally. Next, add event notifications. Drag the timeline to frame 15. To see that the character is now holding the weapon from his back. Right-click in Notify. Select Add Notification, then New Notification. Name it Unequip Stand. Make sure the event is in frame 15. When the animation finishes playing, an event is required to notify the animation that it has finished playing. The character status will be marked. When this event is received, right-click in Notify, named Unequipped End Stand. Drag to the last frame of the animation. Save. We've added a total of 2 events. These events are responded to in the character animation blueprint. Open character animation blueprint. Adding an event response to an event graph. Get 2 events. Add an event to be named Event Unequip. Add event to be named Event Unequip End. Send event. Compile and save. Move the animation montage file to the montage folder under Character. Next, make the crouch equip weapon animation montage file. Right-click on the AS crouch equip animation and select Create Animation Montage. Modify slot to upper body. Reopen the file. And the animation usually appears. Adding event notifications. Drag the timeline to frame 15. To see that the character is now holding the weapon from his back, right-click in Notify. Select New Notification. Name it Unequip Crouch. Make sure the event is in frame 50. When the animation finishes playing, an event is required to notify the animation that it has finished playing. The character status will be marked when this event is received. Right-click in Notify, New Notification. Name it Unequip End Crouch. Drag to the last frame of the animation. Save, close. Respond to the event in the character animation blueprint. Adding an event response to an event graph. Set event. Compile and save. Move the animation montage file to the montage folder under character. Next, create an animation montage file for the pawn with the hold gun. Right-click on the AS pawn equip animation and select Create Animation Montage. Modify slot to upper body. Reopen the file. Adding event notifications 70. Dragging the timeline to frame 17. You can see that the character is now holding the weapon from his back, and the event will be notification named unequipped pawn. Make sure the event is in frame 17. When the animation finishes playing, an event is required to notify the animation that it has finished playing. The character status will be marked when this event is received. Right-click in Notify, New Notification, named Unequipped and Pawn. Drag to the last frame of the animation. Save, close. Respond to the event in the character animation blueprint, adding an event response to an event graph. Send event. Adding comments. Compile and save. Move the animation montage file to the montage folder under character. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, we are going to create an animation montage of a take-back rifle. Right-click on the AS Stand Unequip animation and select Create Animation Montage. Double-click to open the file. Modify slot to upper body. Reopen the file, and the animation displays normally. Next, add event notifications. Drag the timeline to frame 9 to see that the character is now take back the weapon from his back. This time, you need to send an event, and receiving it will place the weapon on the character back. Right-click in Notify, select Add Notification, then New Notification. Name it Unequip Stand. Make sure the event is in frame 9. When the animation finishes playing, an event is required to notify the animation that it has finished playing. The character status will be marked when this event is received. Right-click in Notify, named Unequipped and Stand. Drag to the last frame of the animation. Save. Open character animation blueprint, adding an event response to an event graph. Get 2 events. Add an event to be named Event Unequip. Add event to be named Event Unequip and. Send event. Compile and save. Move the animation montage file to the montage folder under character. Right-click on the AS Crouch Unequip animation and select Create Animation Montage. Modify slot to upper body. Reopen the file. and the animation usually appears. Adding event notifications. Drag the timeline to frame 9 to see that the character is now take back the weapon from his bag. Right-click in Notify. Select New Notification. Name it Unequip Crouch. Make sure the event is in frame 9. When the animation finishes playing, an event is required to notify the animation that it has finished playing. The character's status will be marked when this event is received. Right-click in Notify, New Notification. Name it Unequip End Crouch. Drag to the last frame of the animation. Save, close. Respond to the event in the character animation blueprint. Adding an event response to an event graph. Set event. Compile and save. Move the animation montage file to the montage folder under character. Next, create an animation montage file for the pawn with a take-back weapon. Right-click on the AS pawn unequip animation and select Create Animation Montage. Modify slot to upper body. Reopen the file. Dragging the timeline to frame 90, you can see that the character is now take back the weapon from his bag. Select Add Notification, named Unequip Pawn. Make sure the event is in frame 90. When the animation finishes playing, an event is required to notify the animation that it has finished playing. The character status will be marked when this event is received. New notification, named Unequipped and Pawn. Drag to the last frame of the animation. Save, close. Respond to the event in the character animation blueprint, adding an event response to an event graph. Send event. Adding comments. Compile and save. Move the animation montage file to the montage folder under character. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, we're going to create an animation montage of changing magazines and bullets. Use the same montage animation for the standing and crouching positions. The prone position uses a separate montage animation. Changing magazines and bullets in the same pose use the same animation sequence. So only one animation montage file needs to be created. Both functions are achieved by controlling the position of the playing animation. First, let's create the standing animation montage file. Right-click on the AS stand reload animation and select Create Animation Montage. Double-click to open the file. Modify slot to upper body. Reopen the file, and the animation displays normally. When the animation finishes playing, an event is required to notify the animation that it has finished playing. Right-click in Notify, New Notification. Name it Reload End. Drag the last frame of the animation. Next, we add the bullet changing session. Dragging the timeline to around frame 28. You can see that at this point, the character has finished the magazine change animation and is ready to start the bullet change action. From here is where the bullet change animation will start. Create a session of the bullet sweep here. Right-click and select the new montage session. Name it Reload Bullet. Adjust the position to the 28th frame. Save. We have added a total of 1 event. These events are responded on in the character animation blueprint. Open character animation blueprint. Adding an event response to an event graph. Right-click and enter the event name. Add an event named Event Reload End. Send the event. Compile and save. Move the animation montage file to the montage folder under character. Next, create a montage of magazine changing and bullet changing montages for the prone position. This is done in the same way as in the standing position. Create the animation montage file for the prone position. Go to the folder. Right-click on the AS prone reload animation and select Create Animation Montage. Modify slot to upper body. Reopen the file. And the animation is displayed normally. When the animation finishes playing, an event is needed to notify the animation that it has finished playing. Right-click in Notify and select New Notification. Name it Prone Reload End. Drag the event to the last frame. Next, we add the bullet changing session, dragging the timeline to around frame 36. You can see that at this point, the character has finished the clip change animation and is ready to start the bullet changing action. From here is where the bullet change animation will start. Create a session of the bullet swap here. Right-click on the session area. Name it Reload Bullet. Adjust the position to the 36th frame position. Save. Events are responded to in the character animation blueprint. Open character animation blueprint. Adding an event response to an event graph. Right-click and enter the event name. Send event. Add comment. Compile and save. Move the animation montage file to the montage folder under character. That is for this lesson. Thanks for watching and hello everyone, I'm Big Cat. This lesson is about creating shooting-related animated montages. First, create a stand shoot animated montage file. Right-click AS Rifle Stand Fair Animation and select Create Animation Montage. Double-click to open the file. Modify the slot for upper body. Reopen the file, and the animation displays normally. When the animation finishes playing, an event is needed to notify the animation that it has finished playing. Create a new notification in Notify. Name it Stand Fair End. Drag the event to the last frame. Save. Close. Next, create the crouch shot animation montage file. Right-click the AS Ref Crouch Fair animation and select Create Animation Montage. Open the file. Modify the slot for upper body. Reopen the file, and the animation displays normally. When the animation finishes playing, an event is needed to notify the animation that it has finished playing. Create a new notification in Notify. Name it Crouch Fair End. Drag the event to the last frame. Next, create the Prone Fair Animation Montage file. Right-click on AS Rifle Prone Fair Animation and select Create Animation Montage. Open the file. Modify the slot for upper body. Reopen the file, and the animation displays normally. When the animation finishes playing, an event is needed to notify the animation that it has finished playing. Create a new notification in Notify. Name it Prone Fair End. Drag the event to the last frame. The event is responded to in the character's animation blueprint. Open the character's animation blueprint. Add the event response in the event graph. Right-click and enter an event name. Add the event and name it Event Fair End. Send the event. Add comment. Compile and save. Move the animation montage file to the montage folder under character. That's it for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, I'm going to create an animation montage related to using objects. First, create a standing use object animation montage file. Right-click on the AS stand use object animation and select Create Animation Montage. Double-click to open the file. Modify the slot to upper body. Reopen the file, and the animation displays normally. We can see that this animation is a looping animation. This animation is used for all the objects used. Each item takes a different amount of time to use. So this animation is a looping animation. Next, set this animation to loop in the montage. By default, there is only one session of this animation. So let's make this session loop. Click this button. Select Default. This will keep looping this default session. Since use the item animation montage requires looping, there's no need to create a play end event. The logic controls to stop the animation from playing. Save. Close the file. Next, create a montage of using object animations in the crouch position. Right-click the AS Crouch Use Object Animation and select Create Animation Montage to open the file. Modify the slot to upper body. Reopen the file, and the animation displays normally. Click this button. Select Default. Save. Close the file. Next, create a montage of objects emitted in the prone position. Right-click the AS Prone Use Object Animation and select Create Animation Montage. Modify the slot to upper body. Reopen the file, and the animation displays normally. Click this button. Select Default. Save. Close the file. Move the animation montage file to the montage folder under Character. That's it for this lesson. Thanks for watching, and we'll see you next. Hello everyone, I'm Big Cat. Starting in this lesson, we're going to start making character-based functions. In this lesson, we'll start by building the character-based component. Open my character. Open the viewport window. As you can see in the components window, there are 4 components by default. The first component is the capsule component, representing the character's border range and is primarily used for collision detection. In general, the capsule should wrap around the entire character model. The second component is the arrow component, which is used to indicate the character's current direction. This component is used when you need to get the current direction of the character. The third one is the skeletal model component, which shows the skeletal model of the character. The last component is the character movement component. This component controls the character's movement behavior. These components will be set up later in the course. First, let's set up the skeletal model associated with the character. select the mesh component. Set the skeletal model to SKM female in the Details panel. Once you are done with it, you can see the character model displayed in the viewport window. Here, you may ask why the middle part of the character is transparent. Here we have used a mask. We will address the character later in the session on making costumes. Set the Z-axis rotation to minus 90 degrees. Once set, the character can be seen in the viewport window with the arrow pointing in the same direction. Currently, the capsule body doesn't not completely wrap around the character model, and the capsule body size needs to be modified. Select the capsule body component. In the Details panel, find half the head of the capsule body. This value represents the capsule's head value from the center to the top or bottom of the capsule. Modify this value to 97. In the viewport, the window sees that the character's head is still outside of the capsule body. However, we see that the character's feet are not at the bottom of the capsule. Select the mesh component. Set the Z-axis value to minus 97.6. This time again, we see that the character's feet are aligned with the capsule's bottom. Next, set the animation class used for this skeletal model. Set the animation class to ManAnime Blueprint. In the viewport window, you can see the skeletal model starting to play a standby animation. Compile and save. In this lesson, we have set the default component in character. That's it for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, we create camera-related functions. In the game, the window presents the content that is displayed by the camera. The camera represents the player's perspective. Before we create the camera, we will create a spring arm. The spring arm is used to automatically retract the camera's position when it hits a geometric object with a collision. This effect will be demonstrated to you later in the lesson. Select the capsule body because we want to create the spring arm underneath it. Click Add Component to create a spring arm. In the spring arm assembly, create a camera component. Select to run as a new window. You can see that what is currently displayed in the viewport where we just created the camera. Next, adjust the camera position. Since the camera is hanging below the spring arm, we only need to adjust the spring arm's position. Select the spring arm. Set the length of the arm to 200. This length is the distance from the camera to the character. Set the head of the spring arm to 100 and 25 to the right. Run. You can see that the character's position is adjusted by default after running. Since we haven't made the character movement and viewport movement yet, we can't do it yet. Compile and save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making mouse control related functions. Hand the mouse to rotate the character left and right in the game, and the viewport will turn left and right. Moving the mouse up and down will cause the viewport to rotate up and down accordingly. Let's start by creating a mouse pinning function. Open my character. Add a function named mouse turn. This function will perform the logic of character rotation. Set the category to mouse input. Add input parameter named axis value. Set the type to float. This parameter is used to receive the axis value parameter in the input event. Single right-click to create Add Controller Yaw Input node. The purpose of this node is to add the rotation value. connect executes and connect parameters, compile and save. Next, make a response to the mouse panning event. Open my player controller. Open the full blueprint editor. We will often call functions from character in the controller, so get a reference to the character object at the start of the controller execution and store it in the controller for later use. First, get the current character from the getPlayerController node. Convert it to myCharacter. Promote the return value to a variable. Name it myCharacterRef. Add comments. Right-click in Event Graph to add the turn event. This event was created in the previous project setup class. Call the mouse-turn function in character. Set parameters. Compile. Run the game. Move the mouse horizontally to see the viewport follow the mouse. We found a problem when the mouse is displayed by default when running, and you need to click the on-screen mouse to start controlling the character. Let's deal with this problem. Call the Set Input Mode Game Only node when the controller starts executing. Set player controller as self. Run it again. You can see that the default mouse is not displayed, and you can start controlling the character directly. Next, create the viewport move up and down logic. Open myCharacter. Add a function named mouseLookUp. In this function, the logic for moving the viewport up and down will be executed. Set category to mouse input. Add an input parameter named access value. Set the type to float. This parameter is used to receive the access value parameter in the input event. Create the addControllerPitchInput node. The purpose of this node is to add the rotation value, connect the parameter, compile, and save. Next, create an event that responds to the up and down mouse movement. Open myController. Right-click on the event graph to add the lookup event. Call the mouseLookUp function in character. Set the parameters. Compile. Run the game. Moving up and down the mouse character does not cause any reaction. Select the spring arm component. Check Use Pawn Control Rotation. Run the game. The viewport can already be changed by moving the mouse up and down, but currently the viewport moves in the opposite direction to the mouse. Open my player controller. Multiply the value by -1 and then set it to the function. Run the game. Move the mouse up and down. You can see that the viewport follows the mouse, but I think the viewport is following the mouse too fast. How fast the viewport moves depends on input access value. Change the viewport by multiplying by a number as you move the mouse up and down. multiply by -1 to multiply by -0.5. Run the game. Now move the mouse, and the viewport moves much more comfortably than before. Add comment. Compile, and save. That's it for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, we're going to create a character movement related function. Open the event graph of my player controller. Add function named moving on the ground. Here, we will complete the logic related to moving the character on the ground. Move is divided into backward and forward and left and right. There needs to be a parameter to distinguish the direction of the move. Add a parameter named forward. Of type boolean. This parameter is true if the move is forward or backward, otherwise it is false. Add a parameter named access value. Of type float. A keyboard event moves the character. This parameter is access value of the keyboard event. If this value is 1, then the WOD key is pressed. If this value is -1, it means that the SOA key is pressed. If the value is 0, the key was not pressed to move the key. First, we get the controller's rotation value. We only need the direction value of the Z-axis. Create a rotator and set only the Z value. With this rotator, we get a forward vector and the right vector. The forward function determines the direction of movement. The add movement input node is called via my character. The purpose of this node is to increase the movement speed of the character. Set the direction according to the judgment. Set the scale value. For better readability of the blueprint, change the input parameters to local variables. Then use local variables. Compile, save. Next, make the response move event. Go back to event graph. Create the move forward event. Create the move right event. Call the moving on the ground function separately. Set access value separately. Check the forward parameter when moving forward. Add comment. Run the game. Press WOS key to move the character forward or backward. Press A or D to move the character to the left or right. Careful students may note that the character animation is not working when moving backward, which is caused by not adjusting the movement speed correctly. This will be addressed later in the lesson. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In the last lesson, we made the character movement feature. Run the game. We found that the character instantly went from 0 speed to 600 speed when we start moving, and was also very blocky at max speed to freeze. We wanted to smooth the transition of the character's speed. Before we create a smooth increase in speed, let's add an input parameter. Add the variable named walk speed. Tab float. And category move. This parameter represents the content character's maximum move speed value. Set this value to control the character's maximum movement speed, which will vary when the character is in a different pose or state. Compile. To test the effect, set the different value to 600. Open Moving on the Ground. Gradually add the maximum character movement speed before adding the character's movement speed. Get the character movement while my character. Then you can get the speed vector. And by getting the length of this vector, you can get the current character movement speed. Add 5 to the current speed. This represents an increase of 5 per frame. Determine if this speed is less than or equal to the maximum speed. If the maximum movement speed is not exceeded, set this value to character movement's maximum speed. To make the blueprint more readable, turn this part of the blueprint to nodes and name it Smooth Increase. Double-click to enter. Add the input parameter, named Execute. Tap EXEC. Connect to the branch. If the maximum movement speed exceeded, set the maximum speed for character movement to walk speed. Add the output parameter, named Zen. Tap EXEC. Connect to the output node. Return to moving on the ground. Connect the nodes. Run the game. Press the W key. The character already has a noticeable smooth acceleration effect. Compile, save. Next, make the speed smoothing reduction. Open my character. Select character movement. Check the Use Separate Braking Friction box. Checking this option will start the friction reduction for the character. Run the game. When the Move button is lifted, the character will have a noticeably smoother deceleration. Compile and save. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. When the Alt key is pressed, move the mouse to rotate the viewport without affecting the character's current movement direction. In this lesson, we're going to create this feature. Let's start by changing a few default values. Open my character. Select the root component in my character. Find the Use Controller Rotation yaw in pawn and uncheck it. Later, we decide when to use the controller's rotation through our controls. Next, make the character follow the rotation of the mouse. Open My Player Controller. Create an event take event. This event will be triggered in every frame when running. Add the sequence node. Get the value of the controller's rotation. Add Set Actor Rotation node. Set at each frame. Here, we only need to set the Z value of the actor. Split the return value. Set the Z value. Compile, save. Run the game. The character follows the mouse rotation. Next, move the mouse to rotate the perspective without affecting the character direction when the Alt key is pressed. Get the Alt key event. Add a variable named Alt pressed of type Boolean category input, used to indicate whether the Alt key is currently pressed or not. When the Alt key is pressed, set Alt pressed to true. When the Alt key is released, set Alt pressed to false. It is necessary to record the camera's rotation value when the Alt key is pressed. Since the camera is hanging on the spring arm, we need to get the spring arm's rotation value when the Alt key is pressed. Record the current rotation value. It is named Alt pressed rotation. Category input. When the Alt key is released, record the current rotation value, named Alt released rotation. Category as input. These two variables will be used in many later calculations. Add a determination of whether the Alt key is currently pressed or not when synchronizing the rotation value. If the Alt key is not currently pressed, the rotation value will be synchronized. Add comment. Run the game. When the Alt key is pressed, move the mouse, and the viewport follows the mouse rotation. but the character doesn't not rotate. Set the Alt key pressed state to be false when the Alt key is released. Run the game. When the Alt key is released, the character rotates to the viewport position, but now rotates momentarily. We want the viewport to automatically return to the position it was in before the Alt key was pressed when the Alt key is released. Next, we will animate the shot back by using a timeline. Create a timeline and name it TL Camera Restore. Connect it to Play from Start. Double-click to open the timeline. Set the length to 0.3. This means that the timeline will play for 0.3 seconds. Create a track of type float. Single right-click on the track to add a key point. Set the time of this key point to 0 and the value to 0. Add another key point. Set the time of this key point to 0.3 and the value to 1. Single these two buttons to see the full track. This timeline will be executed from this 00 position to the 0.31 position. Right-click on the 00 point and select User. This will allow us to adjust the curve. Adjust it to be first fast and then slow. Right-click on the stand-alone track name and select Rename. Name it Percentage. Go back to Event Graph. Every time the timeline animation plays, an update will be performed. We want to set the rotation value of the controller each time the update is performed. Get the lerp node of type rotation. In this node, A and B are the two rotation values. Alpha is the percentage value. If it is 0, then A is returned. If it is 1, then B is returned. Shortest path is very important. If checked, it means that the shortest path from A to B is selected. This variable needs to be checked. Set the value of A to out-released rotation. Set the value of B to out-pressed rotation. Set the percentage in the timeline to alpha. Set the return value. Change to see the Alt key press false again after the animation plays. Delete the node. Run the game. Hold down the Alt key to move the mouse, and release the mouse to restore animation. Add comment. Add comment. Compile. Save. That's it for this lesson. Thanks for watching, and we'll see. Hello everyone, I'm Big Cat. In the last lesson, we made the ability to move the viewport freely by pressing the Alt key. However, there will be problems if the character is moving. Run the game. Move the character while holding down the Alt key. The direction the character moves will follow the direction the mouse moves. which is not what we want. We want the character to move in the same direction as before the Alt key was pressed. Open My Player Controller. Open Moving on the Ground. This is where we get the current controller's rotation value. Change this value to a parameter. Add an input parameter named controller rotation. Tap Rotator. Here change this to the input parameter. Compile and save. In response to the move event, add a determination of whether the current Alt key is pressed or not. To make the blueprint more readable, select Judgment, right-click, and choose Collapse to Function, named Get Controller Rotation. Go to Get Controller Rotation. Add the output variable. Name it Rotation. Tap Rotator. Select Pure. Add a local variable. Name it Return Rotation. Tap Rotator. This local variable is valid only within the current function, in the same way that we write code to define a variable within a function. If the Alt key has been pressed, the rotation before it was pressed is used. If the Alt key is not pressed, the rotation of the current controller is used. Finally, this rotation value is returned. Go back to Event Graph. Connect node and parameter. Round game. Pressing the Alt key to move the mouse during a move doesn't not affect the character's original movement direction. Compile and save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. The character has 4 poses on the ground. One is standing, one is crouching, one is prone, and one is jumping. In this lesson, we're going to make a switch between these 4 poses of the character. First, let's make the crouch switch function. Respond to the crouch keyboard event. Determine if currently prone. If it is prone, then set prone to false. And crouch to true. The character goes from prone to crouch. If it is not prone, determine if it is currently crouching. If it is crouching, set the crouch state to false. The character goes from crouching to standing. If not crouching, set the crouching pose to true. The character goes from standing to crouching. Run the game and press the C key to see that the character can go from standing to crouching position. Press the C key again to go from crouching to standing pose. Add the pawn to crouch comment. Add the crouch to stand comment. Add the stand to crouch comment. Add comment. Next, make the pawn switch function. Respond to the pawn keyboard event. Determine if the content position is pawn. If it is pawn, set pawn to false. The character goes from pawn to standing up. If the character is not pawn, determine if the character is crouching. If the character is crouching, set crouching to false. And pawn to true. The character goes from crouching to pawn. Here, you also need to set the aiming state to false. If the character switches to pawn, this process cannot be aiming. If the character is not crouching, it means the character is standing. Set pawn to true. The character goes from standing to pawn. Here, you also need to set the aiming state to false. If the character switches to pawn, this process cannot be aiming. Run the game and press C to see that the character can go from standing to pawn. Press C again to go from pawn to standing. Press C and then C. The character goes from a crouching to pawn. Press the C key to move the character from pawn to crouching. Add the pawn to stand comment. Add the crouch to pawn comment. Add the stand to pawn comment. Add comment. Next, make the jump function. Respond to jump keyboard event. Determine if the current position is prone. If it is prone, set prone to false and crouching to true. The character goes from prone to crouching. Determine if the character is currently crouching. If it is crouching, set crouching to false. The character goes from crouching to standing. If the character is currently standing, then call drop. Run the game, press the space bar, and the character jumps. Press the space bar will change to crouching. Then press the space bar again to change to standing. Add the prone to crouch comment. Add the crouch to stand comment. Add the jump comment. Add comment. Compile and save. That's it for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In the last lesson, we made the character pose a switching feature. The character cannot move when switching to the prone. When it comes to the pose, switching related to the prone position. When the prone position's translation animation is playing, the character cannot move. The disallowed time is the transition animation play time. We keep track of this time by creating a date table in the blueprint folder. Create a new folder named Datas. All static data will be placed in this folder. Create a new folder in the Datas folder named Data Table. This folder holds all the data table files. Create a new folder in the Datas folder named Table Structure. This folder holds all the structure files that are needed for the data table. Create a structure in the Table Structure folder and name it st_prone_time. Open. We only need one variable for this table. Name it sec and type it float. It indicates the number of seconds needed for the transition animation. Save close. Create a data table in the data table folder. Select st_prone_time. Name it dt_prone_time. Open. Add a row of data. Row name is set to false, prone, crouch. False means unarmed. Prone means currently prone. And crouch means target position is crouch. Friend the animation of the transition from prone to crouch for unarmed. The duration of the animation is 1.267 seconds. Go back to the data table and set the unarmed transition seconds from prone to crouch to 1.267 seconds. Add a row of data. Row name is true prone crouch. It means the gun state from prone to crouch transition animation. Here, you can open the animation and see the number of seconds according to the mouse just described. Later, in order to save time, I've checked the number of seconds of all the animations in advance so that I won't open them one by one. Set the number of seconds to 1.567. Add a row of data. Row name is set to force prone stand. Set the number of seconds to 1.4, indicates the animation of the transition from prone to stand unarmed. Add a rule update. Rule name is set to true prone stand. Set the number of seconds to 2.667, indicates an animation of the gun state transition from prone to standing. Add a rule update. Rule name is set to force crouch prone. Set the number of seconds to 0.967, indicates an animation of transition from crouching to prone in the unarmed state. Add a rule update. Rule name is set to true crouch prone. Set the number of seconds to 1.467, indicates a crouch to prone transition animation for the armed state. Add a rule update. Rule name is set to force stand prone. Set the number of seconds to 1.167, indicates an animation of the transition from standing to prone in the unarmed state. Add a rule update. Rule name is set to true stand prone. Set the number of seconds to 2.333, indicates that the gun state is animated from stand to prone. We have now configured all the animation times for the prone transition. Save, close. Open my player controller. Add a variable. Name enable move. Type boolean. Category action. This is used to indicate if the current character is movable or not. By default, the character can be moved, so you need to set the default value to true. Find the response to move the event area. Determine if the character is currently movable before moving it. Create a macro named hold position. This is used to prohibit the character from moving for a certain period of time. This macro does not need to have a return parameter. Add input parameter named execute of type exec. This will create an execution node. Add an input parameter named isHoldWeapon of type boolean, indicates if the gun is currently held. Add an input parameter named current of type string, indicates the current pulse. Add an input parameter named target of type string, indicates the target pulse. Get the get date table row node and set the date table to dt prone time. Append the string by the input parameter. split the return value. Set disable mode. Call the delay node. After the delay is complete, allow the move. Return to event graph. Call the macro when switching a prong-related pause. Find the crouch key event response area. Called when prong to crouch. Find the prong key event response area. Called when prong to standing. Called when crouching to prong. Called when standing to prong. Run the game so that all transmission animations associated with the prong do not move the character while playing. Compile and save. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. When the mouse controls up or down, it controls the character's pitch angle. Up will have a maximum limit, and down will have a minimum limit. Open the event graph of my player controller. Find the mouse input area. Now we don't have any limit. The mouse movement will set the pitch angle in real time. Add function named limit pitch angle. Category input. Use it to check if the pitch angle limit is exceeded. Add input parameter named axis. Type float indicates the axis value of the input event. Add a return parameter named inScope. Of type boolean indicates if the event is within range. First, calculate the maximum and minimum values of the pitch angle based on the current character state. Add sequence. Let's first see what the maximum and minimum values of the pitch angle are with no restrictions. Get the controller rotation values. Print. Go to event graph. Call the function in tick. Run the game. We found that the different state pitch angle for a freight wheel is 0. When the character looks at the bottom, it is 270. When looking at the top, it is 90. That means the pitch angle range is greater than 270 or less than 90. In the standing, the limit value for looking to the lowest position is 290. Limit the value to look to the highest level is 75. Switch to crouch. When crouching, the limit value for looking at the lowest position is 290. Limit the value to look to the highest level is 50. Switch to prong. When prime, the limit value for looking at the lowest position is 350. Limit the value to look to the highest level is 50. Delete the call function from the tick. Delete the print. Add a local variable named bottom value. Type float. Indicate the value at which the character will look lowest. Add a local variable named top value of type float. Indicates the value that the character is looking highest. Determine if the actor is currently prone. If it is prone, set the bottom value to 350 and the top value to 50. If it is not prone, judge whether it is crouching. If it is crouching, set bottom value to 290 and set top value to 50. If it is not a crouching posture, it is a standing posture. Set the bottom value to 290 and set the top value to 75. Add comment. Then, we determine if adding this excess value to the limit will exceed the limit. Get the controller's rotation value. Split. Sum it with its pitch value. Add excess and multiply it by the input pitch scale value. When we call the add controller pitch input node, it uses the current pitch plus equal to input pitch scale multiplied by excess value. The node hence have instructions for this, or you can just look at the source code, determine if the sum is greater than bottom value. Or less than top value. If yes, it proves that the limit is not exceeded. Return true. If not, the result shows that the limit exceeded. Return false. Add comment. Go back to event graph. Call the function and set access. If true, call the function. Run the game. The stand posture limit is correct. Switch to the crouch position. Crouch limits are correct. Switch to prone. The prone limit is correct. Currently, there is a problem. For example, when in standing position, see the bottom, then without moving the mouse. I switch to the prone. At this time, the pitch limit of prone is exceeded and the mouse cannot control it. So after switching posture, first judge whenever the current pitch angle has exceeded the limit. Directly set to the border if it exceeds the limit. Open the limit pitch angle function. Before judging whether the limit is exceeded by increasing the rotation value. The first judge whether the limit has been exceeded without increasing the rotation value. If the limit is exceeded, then subtract the top from the current pitch. Subtract the top value from the current pitch value. Take the absolute value. Sum. Subtract bottom value from the current pitch value. Take the absolute value. Make the comparison. If it is less than, call to set the rotation value of control. Set the pitch value with top value. Set the values of the x and z axes with the current value. If not less than, set the pitch value with bottom value. Add comment. Connect nodes. Compile, save. Open event graph. Call the limit pitch angle function when the crouch key is pressed. Call the limit pitch angle function when the prong key is pressed. Run the game. Look at the bottom while in standing position. Switch to prong position. You can see that the pitch angle is automatically adjusted to the limit value. Looking at the top also works correctly. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In the last lesson, we made a pose change. In this lesson, we are going to create a camera position change function. We need to create a data table to store the camera position data when the character is in a different pose. Create a structure in the tape structure folder and name it stCameraHead. Open it. The first variable is named height. Type float. Indicates the height value of the camera. Save close. Create a data table in the data table folder. Select stCameraHead. Name it DTCameraHead. Open. Add a row of data. Set the row name to stand. Set the height value to 100. Indicates that the height of the camera when the character is standing is 100. Add a row of data. Set the row name to crouch. Set the height value to 40. This means that the camera's height will be 40 when the character is crouching. Add a row of data. Set the row name to crouch normal move. Set the height value to 60. Indicates that the camera's height is 60 when the character is moving in a crouch and not holding a gun. Add a row of data. Set the row name to crouch rifle move. Set the height value to 80. Indicates that the camera's height is 80 when the character is jogging or running with a gun in a crouch. Add a row of data. Set the row name to prong. Set the height value to -22. Indicates that the height of the camera is -22 when the character is in a prone position. Save close. Data table creation is complete. Open My Player controller. First, add the variables needed to move the camera. Add the variable named Move Right Axis. Type float. Category move. Set this variable in the keyboard event move right. This value will not be 0 if the user has an action character that moves left or right. Add a variable named current head of tape float. Category camera. Indicates the current head of the camera. This value is the real-time head value. Compile. Set the default value to 100. After the game starts, the character's pose is set to standing by default. In the standing position, the camera head is 100. Add a variable named newHeight. Type float. Category as camera. Indicates the new height value of the camera. This value is the target height of the camera. Add a variable named original height. Of type float and category camera. In order to perform an animation of a camera height change, you need to know the starting height. This value is used to record the starting point. Next, the moving camera function is created. Add a custom event in the event graph, named update camera height. It is used to update the camera position. The logic here is in two parts. In the first part, we calculate the camera's height based on the current pose and the state of the character. In the second part, we calculate the height and compare it with the current camera height. If it is different, we play the camera movement animation. Add the sequence node. Determine if the current pose is a crouch. If it is crouching, get whether the character is holding a gun or not. Add a variable named moveForwardAxis. Of type float, category move. Set this variable in the keyboard event moveForward. This value is not zero when the operation character moves left or not, or right. Get the value of axis when moving forward or backward. Determine not to be zero. Get the value of axis to move left or right. Determine that it is not zero. If one value is not zero, then the character is moving. Determines if the character is currently not holding a gun and is moving. If so, get the crouching unarmed movement data from the camera head data table. Set the head value to the new head variable. If not, copy and paste. Change, determine if a gun is not held, to determine if a gun is held. If it is gun move, get the crouching gun move data from the camera head data table. Set the head value to the new head variable. If the movement is not with a gun, get the date for the camera head data table's crouching position. Set the head value to the new head variable. If it is not a crouching position, determine if it is a prone position. If it is prone, get the date for prone from the camera head data table. set the head value to the new head variable. If it is not brown, get the date for the standing position from the camera head date table. Set the value of the head to the new head variable. Add comment. Move position. Determine if the current camera head value is equal to the target head value. If not, first set the current head value to the original head variable. Add a timeline named TL update camera head to move the camera head animation. Open the timeline. Set the total duration of the animation to 0.7 seconds. Create a track of type float named percentage. Add a key point and set time to 0 and value 0. Add another key point, set time to 0.7 and the value to 1. Right-click the first key point and set it to user. Adjust the curve to fast and then slow. Return to the event graph. The position of the spring arm is updated every frame the animation is executed. Expand location. Get the position of the spring arm. Expand. The X and Y values of the spring arm do not need to be changed, just set them. Add lerp node. Set position A to original head. Set position B to new head. Set alpha to the position tag value of timeline. Set the Z value. Update the current head value. Add comment. Add comment. Next, invoke the update camera head event when the character changes pose or when changing state. First, the crouch response. Call to update the camera head after a pose change. Find the prone response. Call the update camera head event after changing pose. Find the jump response. Add the sequence node. Calls to update the camera head after switching pose. Find the move input event. Before controlling the character's movement, decide if you want to call to update the camera head or not. Add a sequence node. Move the node position. Determine if the recorded access value is different from the current live value. If they are different, the character has changed from stationary to moving or from moving to stationary. Set the axis to the latest value. And call update camera head function. Add comment. Add comment. The same logic applies to moving left and right. Add the sequence node. Move the node position. Determines if the recorded access value is different from the current real-time value. If it is different, the character has changed from stationary to moving or from moving to stationary. Set the axis to the latest value and call the update camera head function. Add comment. Add comment. Compile, save, next test, run the game. Toggle the pose. The height of the camera follows the change in pose. The height of the camera changes correctly. Open my character and set the gun holding status to true. Run the game. Crouch with gun moving. The height of the camera has changed correctly. We have now finished updating the camera head change. Set the gun status to false. Compile. Save. That's it for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In the previous lesson, we made a feature about switching character pose and how different poses can affect the speed at which your character moves. In this lesson, we'll look at the different speed that our characters move on the ground. Let's start with this picture. The character can move in a total of 8 directions. The blue arrows indicate left front, forward, and right front, all of which move at the same speed when in the same pose. The green arrows indicate left, right, left back, and right back, and these directions move at the same speed when in the same pose. The character is divided into 3 poses: standing, crouching, and prone. All 3 poses have an unarmed and armed state, respectively. The different poses move at different speeds. The character has 4 states: walking, jogging, running, and aiming. when the control key is held down simultaneously to move, the character is walking. When no actual key is pressed to move, the character is jogging. When the shift key is pressed and held to move, the character is running. When moving with the right mouse button or right mouse button held down, the character is aiming for the state. The character moves at different speeds depending on the state. Note here that there is no wrong state, either the unarmed or armed state, if you are currently prone. So the speed value here is the same as the jogging speed value. Next, let's look at the aiming state. The unarmed state can't aim, so there's no speed. No movement is allowed when aiming from prone position, so there's no speed. Running only has actual speed value in the forward direction, so the speed value in other directions is the same as jogging speed value. Since the unit of velocity in Unreal Engine is centimeter per seconds, all the values I've listed here are in centimeter per seconds. Let's create a data table to store these velocity values. Open the project. Create a structure in the table structure folder and name it stWalkSpeed. Open. The first variable is named forward. Type float indicates the value of the speed in the 3 forward directions. Create a new variable named other of type float. Indicates the velocity value for the other 5 directions. Save. Close. Create a data table in the data table folder. And select stWalkSpeed. Name it dtWalkSpeed. Open. Add a row of data. Row name is set to false stand walk. Indicates the speed value of the unarmed state stand walk. Set forward to 175 and other to 158. Add a row of data. Row name is set to false stand jog. The value of the speed of unarmed standing jogger. Set forward to 500 and other to 333. Add a row of data. Row name is set to false stand run. The value of the speed of unarmed stand run. Set forward to 625, other to 333. Add a row of data. Row name is set to true stand walk. The value of the speed of the standing walk in the armed state. Set forward to 170 and other to 150. Add a row of data. Row name is set to true stand jog. The value of the jogging speed for the gun status. Set forward to 490 and other to 300. Add a row of data. Row name is set to true stand run. The speed value of stand run when the gun is held. Set forward to 600 and other to 300. Add a row of data. Row name is set to true stand aim. The value of the velocity of the gun standing and aiming. Set forward to 180 and other to 151. Add a row of data. Row name is set to false crouch walk. Crouch walk speed in unarmed state. Set forward to 135 and other to 190. Add a row of data. Row name is set to false crouch jog. The value of the crouch walking speed in unarmed state. Set forward to 333 and other to 238. Add a row of data. Row name is set to false crouch run. The value of crouch run speed in unarmed state. Set forward to 476, other to 238. Add a row of data. Row name is set to true crouch walk. The speed of the crouch walk in the gun state. Set forward to 130, other to 100. Add a row of data. Row name is set to as true crouch jog. The value of the speed of the crouch jogging state set forward to 320, and other to 220. Data row update. Row name is set to true crouch run. The speed of crouch run in gun state. Set forward to 460, and other to 220. Data row update. Row name is set to true crouch aim. Set forward to 138, and other to 90. Add a row update. Row name is set to false prone work. The speed value of the unarmed prone work. Set forward to 49, other to 30. Add a row update. Row name is set to false prone jog. The value of jogging speed in unarmed position. Set forward to 190 and other to 100. Add a row update. Row name is set to false prone run. The value of the speed of unarmed prone run. Set forward to 190 and other to 100. Add a row update. Row name is set to true prone walk. The speed of the walking while holding the gun. Set forward to 40 and other to 25. Add a row update. Row name is set to true prone jog. The value of the jogging speed when the gun is held. Set forward to 110, other to 90. Add a row update. Row name is set to true prone run. This is the speed of the gun running state. Set forward to 110 and other to 90. Now all the speed values for the different states have been entered. Save. That's it for this lesson. Thanks for watching, and we'll see you next. Hello everyone, I'm Big Cat. In the last lesson, we create a character speed value data table. In this lesson, we will create the effect of pause on speed. In the default state, the character moves as a jogger. Only pressing the relevant button will toggle the movement state. First, let's make the switch in response to the movement state. Open the event graph of Mac Player Controller. Respond to the jogging button. Create a variable named work pressed of type boolean. Category input used to indicate whether the current jog away key is pressed. Set the variable. Respond to the run key. Create a variable named run pressed. Type boolean and category input used to indicate whether the current run key is pressed or not. Set variable. Add comment. Next, create the function that will be used to update the speed. Add a function named update work speed. Category move. Add a local variable named hold weapon. Type string indicates if the gun is currently held. Add a local variable named posture of type string indicates the current character pause string. Add a local variable named move state type string indicates the current character state string. Next, set these three local variables. Add the sequence node. Convert the isHold weapon variable to type string and set it to the hold weapon variable. Determine via myCharacterRef if the character is currently in a prone position. If it is a crouch, set posture to crouch. If it is not crouch, determine if it's prone. If it is prone, set posture to prone. If it is not prone, then it is standing. Set the posture to stand. Next, determine the character state. Determine if the character is currently in aiming position. If it is, set move state to aim. If the aim button is not pressed, determine if the jog button is pressed. If yes, set the move state to work. If the jog key is not pressed, judge whether the run key is pressed. If yes, set move state to run. If the run key is not pressed, set move state to jog. Add a comment. Next, determine the direction of the character's movement. Go back to the event graph. Find the move input session. We can determine whether the current character's movement direction is forward or not by determining whether the forward key is pressed. Go to Update Work Speed function. Based on the three values set earlier, supplies the string. Query the date table by the spliced values. Expand the returned value. Determine if the excess value of the forward direction button is greater than 0. If greater than 0 means the current character is moving the forward direction, set the speed value to work speed. This completes the process of getting maximum movement speed by character pose and state. Add comment. Compile, save. Next, you need to call the update movement speed function. Open the event graph. Call the move speed update function when the character is ready to move. compile, and save. That is for this lesson. Thanks for watching, and we'll see you next time. Hello everyone, I'm Big Cat. In the last lesson, we made characters with different movement speeds, and in this lesson, we are going to test what we did in the last lesson. For better testing, we'll print the current character movement speed value in event tick in real time. Run. Press the W key or the WA key or the WD key at the same time. The maximum speed of the character is 500. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 333. Continuously hold down the Ctrl key and press the W key, or press the WA key or press the WD key at the same time. The character's maximum speed is 175. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 158. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The maximum speed of the character is 625. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 333. Next, test the crouch position. Press the C key to switch to the crouch position. Press the W key or the WA key or the WD key at the same time. The character's maximum speed is 333. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 476. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 238. Continuously hold down the Ctrl key and press the W key or press the WA key at the same time, or press the W key or press the WD key at the same time. The character's maximum speed is 135. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the characters is 190. Next, test the prone position. Press the Z key to switch to the prone position. Press the W key or the WA key or the WD key or both at the same time. The maximum speed of the character is 190. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 100. Continuously hold down the Ctrl key and then press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 49. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 30. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 190. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 100. Next, test the gun holding state. Open my character. Set the is hold weapon variable to true. Compile and run the game. Press the W button or the WA button or the WD button at the same time. The maximum speed of the character is 490. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 300. Continuously hold down the Ctrl key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 170. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 150. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 600. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 300. Next, test the crouch position. Press the C key to switch the crouch position. Press the W key or the WA key or the WD key at the same time. The character's maximum speed is 320. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 220. Continuously hold down the Ctrl key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 130. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 100. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 460. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The maximum speed of the character is 220. Next, test the prone position. Press the Z key to switch to the prone position. Press the W key or the WA key or the WD key or both at the same time. The maximum speed of the character is 110. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 90. Continuously hold down the Ctrl key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 40. Continuously hold down the Ctrl key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character speed of the character is 25. Continuously hold down the Shift key and press the W key or press the WA key or press the WD key at the same time. The character's maximum speed is 110. Continuously hold down the Shift key and press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 90. Next, test the aiming state. Open my character. Set its aiming variable to true. Compile and run the game. Press the W key or the WA key or the WD key at the same time. The maximum speed of the character is 180. Press the S key or the SA key or the SD key or the A key or the D key at the same time. The character's maximum speed is 151. Press the C key to switch to a crouching position. Press the W key or the WA key or the WD key at the same time. The character's maximum speed is 138. Press the S key or the SA key at the same time, or the SD key at the same time, or the A key at the same time, or the D key. The character's maximum speed is 90. All poses and state character movement speeds are correct. Set its hold weapon and its aiming variables to false. Compile, save. Open my player controller. Delete the text from the tick. Compile and save. That's for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. Starting from this lesson, we are going to make a character fashion change. The fashion change works by splitting the character skeletal mold into multiple parts, each using the same boss. The disassembled part will find its parent skeletal according to its location in the skeletal space, and then synthesize the output. In this lesson, we will create a child skeletal model of our character. Open the viewport of my character. Select Mesh and add a skeletal mesh named SKM Hair. This is used to display the character's hair. Select Mesh and add skeletal mesh named SKM Underwear Top. Show the top of the character's underwear. Select Mesh and add skeletal mesh. Name it SKM Underwear Bottom. This is used to show the character's underwear bottom. Select Mesh and add skeletal mesh. Name it SKM Close Top. This is used to show the character's underwear. Select Mesh and add skeletal mesh. Name it SKM Close Bottom. Show the character's pants. Select Mesh and add skeletal mesh. Name it SKM Hole. This will show the character's bodysuit, such as a swimming suit. Select Mesh and add skeletal mesh. Name it SKM Shoes. This is used to show the character's shoes. Set the skeletal model for the hair to SKM Close Hair 01. Since the character's hair must be displayed and there is only one hair resources, it is set directly. The other skeletal models may change, so there is not need to set default values. Next, we set the initial settings for the skeletal model. Create function named init skeletal mesh. Category skeletal mesh. This is used to initialize the skeletal model associated with the character. Add a create dynamic material instance node with empty skin as the parent class. This material is the material of the character's skin. Promote the return value to a variable named skin mat reef. Category skeletal mesh. Set this material instance to the character model. Since we will need to call this skin material instance later, we have created a new instance here. The name of the slot is skin. This name is defined in the model. Select the mesh component and find the model field location. Open the model. There is a slot name in the place of the skin material. This is the name used when setting the material. Close the model. Go back to my character. Add comment. Create the sequence node. Next, give control of the skeletal model except for the hair to the character master model. Call the set master pose component node and set the mesh component to be the master component. Set the child skeletal model component. Note here that the child skeletal model must use the same skeletal as the main skeletal model to be set up this way. The hair's skeletal model is not set here because the here's skeletal model is a separate skeletal. Add comment. Next, attach the hair skeletal model to the character's main skeletal model. Add the Attach to Component node. The character's main skeletal model to parent. Set the hair skeletal model to target with head slot name. This slot name is the name of the bone in the character's skeletal. Open the SKM female skeletal file. Search for head to see the skeletal with this name head. Close and go back to my character. The position, rotation, and scaling rules are all selected for keep word. Add comment. Open construction script. This function is a constructor for the blueprint, similar to the constructor in the code. This function is triggered to execute when the blueprint is created. Call here to initialize the skeletal model. Compile viewport. The hair is already moving to follow the character's animation, but the position is a bit off. Select the hair skeletal model. Set the position to -1, 4, 0.5. Compile. Save. Run the game. There are still some deviations. Fine tune again. Finally, set the hair position to 1, 1, 1. Run the game. Character here is displayed correctly. Save. That is for this lesson. Thanks for watching. Hello everyone, I'm Big Cat. In this lesson, we are going to create the relevant date needed for the change of clothes. Create a new folder in the Data folder under Blueprint. Name it Anu. All enumeration files will be placed in this folder. Create a new Anu file named eFashionType. Define the type of fashion inside this Anu. Open. Create a new enumeration and name it Clothes Top. Denotes a top. New. Name it Clothes Bottom. This means pants. New. Name it Whole. Indicates a bodysuit. New. Name Shoes. Denotes shoes. Save as clothes. Next, create the date table for fashion. First, create the date table structure that is needed for the date table. Create the folder under Data's Table Structure folder, named Items. All the structure of the date table related to the items will be placed in this folder. Create the structure. Name it ST_item_fashion. Open. The first attribute is name type, and the type is eFashionType. Indicates the type of the fashion. Create a new variable named name. Type test indicates the name of these clothes. New variable named icon. Type texture 2D indicates the small icon. A new variable named skeletal mesh. Type skeletal mesh object reference indicates which skeletal mesh file is used for these clothes. Create a new variable named static mesh of type static mesh object reference indicates which static mesh file is used for the clothes. Save and close. Next, create the fashion date table. Create a folder in the date table folder named items. All item-related date tables are placed in this folder. Create the date table file and select ST_item_fashion. Name it DT_item_fashion. Open. Find the resources for the tops. There are 3 of them. Add a row of data. Set row name to 1. The row name indicates the number of this top. The type is the top. Set the name to blue underwear. Underwear is the default garment and cannot be picked up, so no icon needs to be set. The skeletal model is SKM Clothes Top 01. The default garment does not need a static model. Add a row of data. Set row name to 2. The type is top. Set the name to white vest. Set the icon to icon fashion top white vest. Select SKM Clothes Top 02 for the skeletal model. Select M Clothes Top 02 for the static model. Add a row of data. Set row name to 3. The type is top. Set the name to retro jacket. Set the icon to icon fashion top retro jacket. The skeletal model is selected as SKM Clothes Top 03. Select M Clothes Top 03 for the static model. Find the resources for the pants. There are 3 of them. Add a row of date. Set the row name to 4. The type is pants. Set the name to blue underpants. The default closing does not need to have an icon set. Select SKM close bottom 01 for the skeletal model. The different closing does not require a static model. Add a row of data. Set the row name to file. The tab is pants. Set the name to gray jeans. Set the icon to icon fashion bottom gray jeans. Select SKM close bottom 02 for the skeletal model. Select SKM close bottom 02 for the static model. Add a row of data. Set row name to 6. Tab is pants. Set the name to retro jeans. Set the icon to icon fashion bottom retro jeans. The skeletal model is selected as SKM close bottom 03. Select M close bottom 03 for the static model. Find the resources for the bodysuit. Only one type of swimsuit. Add a row of data. Set the row name to 7. The tab is hole. Set the name to swimming. Set the icon to icon fashion hole swimming. Select SKM clothes swimsuit 01 for the skeletal model. Select M clothes swimsuit 01 for the static model. Find the resources for shoes. Only one type of shoes. Add a row of data. Set the row name to 8. The tab is shoes. Set the name to yellow shoes. Set the icon to icon fashion shoes yellow shoes. Select SKM close shoes 01 for the skeletal mesh. Select M close shoes 01 for the static model. Save and close. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to make a replacement skeletal model feature. Open my character. Create function named replaced skeletal mesh. Tab skeletal mesh. Add input parameter named fashion tab. Tab fashion tab. Used to indicate the tab to be displayed. Add input parameter named name. Tab name. Used to denote the number to be replaced. In the previous lesson, we used the row name from the date table as the number. So here is the name type. Create a switch node by item type. If it's a top, set the top skeletal model. If it's a pant, set the pant skeletal model. If it's a hole, set the whole skeletal model. If it's a shoes, set the shoes skeletal model. Then get the corresponding bone model by item number. This is how you will find the corresponding skeletal model. This part of the blueprint will be reused several times later. To improve the readability of the blueprint, collapse this part of the blueprint into function. It is named getFashionDatas. Category is skeletal mesh. Go to getFashionDatas. Delete all input parameters. Add an input parameter named ID, tab name. Add an output variable named skeletal mesh. Tab skeletal mesh object reference. Connect the output node. Return to the replace skeletal mesh. If no cross-bonding data is found, return the empty skeletal model. Call getFashionDatas. Promote the returned skeletal model to a local variable named skm. Set up skeletal mesh. Add comment. Compile and save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In the last lesson, we created the replace skeletal model feature. So let's test what we did in the previous lesson for this lesson. Open event graph. Add the keyboard 1 key event response and perform the varying of the number 0 top. A number 0 won't find the close, so it means to take off the close. Add a keyboard 2 key event response to perform the varying of the number 2 top. Add a keyboard 3 key event response to perform the varying of the number 3 top. Run the game. Press the 2 key and the character wears a white top. Press the 3 key and the character wears the redder top. Press the 1 key and the character takes off the top. Add a keyboard 4 key event response to perform the varying of the number 0 pants. Add a keyboard 5 key event response to perform the varying of the number 5 pants. Add a keyboard 6 key event response to perform the varying of the number 6 pants. Run the game. Press the 5 key and the character wears green jeans. Press the 6 key and the character wears retro jeans. Press the 4 key and the character takes off the pants. Add a keyboard 7 key event response to perform the varying of the number 0 hall. Add a keyboard 8 key event response to perform the varying of the number 7 hall. Run the game. Press the 8 key and the character wears the swimsuit. Press the 7 key and the character takes off the swimsuit. Add a keyboard 9 key event response to perform varying the number 0 shoes. Add keyboard 0 key event response to perform varying the number 8 shoes. Run the game. Press the 0 key and the character wears the yellow shoes. Press the 9 key and the character takes off the shoes. We found that The top and pants overlap with the bodysuit during testing. Although the skeletal models in all positions are replaced according to the key pressed, the next step was to create a special bodysuit treatment for the function. Open Replace Skeletal Mesh. After replacing the top, determine if you are dressing instead of underdressing. Take off the swimsuit. Determine if you are wearing pants instead of taking them off after replacing pants. Take off the swimsuit. After replacing the bodysuit, judge if you are wearing the bodysuit instead of undressing it. Take off the top and pants. Round game. Press 2 to put on the top. Press 5 to put on the pants. Press 8 to see that the character is wearing a swimsuit and has taken off the top and pants. Press 3 to see the character wearing a top and taking off the swimsuit. Press 8 to see that the character is wearing a swimsuit and has taken off his shirt. Press 6 to see the character in pants and out of swimsuit. Add comment. Compile. Save. That's it for this lesson. Thanks for watching and we'll see. Hello everyone, I'm Big Cat. Currently, the character's skin has some parts that are transparent by default. This is because each close skeletal model doesn't fit perfectly. So there is a corresponding transparent mask for each type of clothing displayed when the clothes are on. First, let's look at the masking principle. Find the character's skin material. Open it. This opacity mask is used to see the opacity mask. With a single texture, you can see the transparent area. Of course, you can overlay multiple textures here. Some parts of the character will be transparent by default because by default, the swimsuit mask is set here. Why do you need a mask? Run the game. The default is to use a swimsuit mask. So, we will use a swimsuit as an example. Press the 8 button and wear the swimsuit. You can see that the swimsuit fits the entire character very well. What happens if you don't use the mask? Open the skin material. Set the top mask to TX empty white. Apply. Save. Run the game. At this point, the character shows full skin by default. Press the 8 key and wear the swimsuit. Look closely at the character's swimsuit and see that there are different levels of skin breakage. The character for the breakage is that the swimsuit model and the skin model are not fitting properly. If you don't use mask, you need the swimsuit to fit the skin model very well, which creates extra work for the artwork. This can be easily solved by using a mask. Restore the default use of the swimsuit mask. Apply. Save. Add the mask resource to the fashion datetable first. Open st_atom fashion. New variable named mask texture. Tab texture object reference. Save, close. Open dt_atom fashion. The texture for underwear is set to tx mask underwear top 01. Texture for wet vest is set to tx mask shirt 01. Texture for retro jackets is set to tx mask fantasy top. Underpants has a texture set to tx empty white. Underpants don't need to be covered, so use this plain white texture. The texture for gray jeans is set to tx mask pants 01. The texture for retro jeans is set to tx mask fantasy bottom. The texture for the swimsuit is set to tx mask swimsuit. The texture for yellow shoes is set to tx mask boots 01. Save, close. Open my characters get fashion datas. Add new output variable named mask texture. Tab texture object reference. Set the return value. Compile, save. Next, set different skin mask based on the skeletal model you are replacing. Open the Replace Skeletal Mesh function. Promote the mask object to a local variable named mask. Set the mask object from the date table to the skin material. Run the game. Press the 2 key, correct. Press the 3 key, correct. Press the 5 key, correct. Press the 6 key, correct. Press the 8 key to find the wrong pants mask. This is because the pants mask was not removed when replacing the swimsuit. Add a new sequence node. If the current bodysuit is not empty, Set the pants mask to txempty white. The txempty white map is a plain white map. Use this map when a mask is not needed. Run the game. Press the 2 key, correct. Press the 5 key, correct. Press the 8 key, correct. Press the 5 key and find the wrong mask for the top. This is because the swimsuit mask was not removed when the pants were replaced. Add a new sequence node. Determines if a top is being worn when not bodysuit is currently being worn. If no top is being worn, set the top mask to txempty white. Determine if pants are worn when there is no bodysuit currently on. If no pants are worn, set the pants mask to txempty white. Run the game. Press the 2 key, correct. Press the 5 key, correct. Press the 8 key, correct. Press the 5 key, correct. Press the 0 key and the character wears a shoes. Press the 9 key and the character's foot is missing. This is because the shoes mask was not removed when the pants were removed. Before setting the shoes mask, determine if the shoes are on at the time. If the shoes are off, set the shoes mask to txempty white. Run the game. Press the 0 key, correct. Press the 9 key, correct. Add comment. Compile. Save. That's it for this lesson. Thanks for watching, and we'll see you next time. Hello everyone, I'm Big Cat. The character is currently incorrectly dressed by default. We want the character to wear underwear and panties by default, and that the character must also wear underwear or panties. When the character takes off their clothes, open my character's replace skeletal mesh. If the character is not currently wearing a top, get the underwear data via get fashion datas. Set the top skeletal model and the top mask based on the data. If not pants are currently being worn, get the underwear data via get fashion datas. Set the pants skeletal model and the pants mask according to the data. Run the game. Press the 2 key. Press the 5 key. Press the 8 key. Press the 2 key to put on the underpants automatically. Press the 8 key. Press the 5 key to put on the underwear automatically. Press the 2 key. Press 1 to automatically put on the underwear. Press the 4 key to put on the underwear automatically. Add comment. Compile. Save. Initially were underwear and pants. Currently, there is still a pipeline with the character initially varying after the game starts. Open the init skeletal mesh function. Add a call to the replace skeletal mesh function. Set ID to 0. Run the game. The character's initial clothing is displayed correctly. Add comment. Find the shoes model. Open the model. You can see that the shoes soles a certain height, so you will need to adjust the height of the shoes when the character wears them. Open my character's replace skeletal mesh. If the character is currently wearing shoes, set the character's height to minus 96.9. If the character is not currently wearing shoes, set the character's height to minus 97.6. Run the game. Press the 0 key and then press the 9 key. You can see the change in the character height. Add comment. Compile. Save. This completes the development of the character costume. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. There are many types of items in the game, and each type has data associated with it. In this lesson, we will start by creating a data sheet for all the items. In this lesson, we will start by creating a weapon data table. Create structure under the Data's table structure items folder, and name it ST item weapon. Open. The first variable is named name, and the type is test. It is used to represent the weapon name. New variable named icon. Type texture 2D. Icon to represent the weapon's icon. New variable named big icon. Type texture 2D. Big icon to represent the weapon's icon. New variable named thumbnail. Tap Texture 2D Object Reference. Thumbnail to represent the thumbnail of the weapon. New variable named useAmmo_id. Tap Name. Indicates the bullet number used for this weapon. New variable named clip size. Tap Integer. Indicates the number of full-loaded bullets in the weapon's default magazine. A new variable named damage. Tap Integer. Indicates the damage value of one bullet for this weapon. New variable named firing interval. Tap Float. This value is used to indicate the time between firing of this weapon. If the value is 0, it means the weapon can't fire continuously and needs to be changed after each firing. New variable named Replace Clip Time. Tap Float. This variable indicates the time in seconds to change the magazine. New variable named Replace Bullet Time. Tap Float. Indicates the time in seconds required to change a magazine. New variable named Tap Boolean. Indicates if the weapon can be switched to full auto mode. New variable named Static Mesh. Of Tap Static Mesh Object Reference. Used to represent the static model of the weapon. New variable named Skeletal Mesh. Of Tap Skeletal Mesh Object Reference. Used to represent the skeletal model of the weapon. New variable named Default Match. Tap Static Mesh Object Reference. The default magazine model used to represent the weapon. What is the default magazine? Find the skeletal model of the M4 weapon. As you can see, the M4 is a weapon that by default has no magazine, no sights, and no backstock. Since these parts are replaceable, they are not available by default. The default parts need to be displayed when the weapon is created. Back to the data structure. New variable named Default Scent. Tap Static Mesh Object Reference. Used to represent the weapon's default sight model. New variable named Default Backstock. Tap Static Mesh Object Reference. Used to represent the default stock model for this weapon. New variable named Fire Sound. Tap Sound Base Object Reference. Indicates the audio file that is played when the weapon is fired. New variable named Fire Sound Suppressor. Tap Sound Base Object Reference. Indicates the audio file that is placed when the weapon is fired with a silencer attached. New variable named Can Sight. Type Boolean. Indicates whether or not the weapon can be mounted with a scope. New variable named Can Muzzle. Type Boolean. Indicates whether or not the weapon can be equipped with a muzzle. New variable named Can Clip. Type Boolean. Indicates whether or not the weapon can be equipped with a magazine. New variable named Can Backstock. Type Boolean. Indicates whether or not the weapon can be mounted with a backstock. New variable named Cross Offset Mean Stillness. Type Float. Indicates the minimum offset of the weapon when the sight is not open and the weapon is not hold-sighted and stationary. New variable named Cross Offset Mask Stillness. Type Float. Indicates the maximum offset of the weapon when the sight is not open and the weapon is not hold-sighted and stationary. New variable named Cross Offset Mean Move. Type Float. Indicates the minimum offset of the weapon when the sight is not open and the weapon is not hold-sighted and moving. New variable named cross, offset, mask, move. Tap float indicates the maximum offset of the weapon when the sight is not open and the weapon is not held, sighted, and moving. A new variable named cross, offset, min, aim, stillness. Tap float indicates the minimum offset of the weapon when the sight is not open and the weapon is held, sighted, and stationary. New variable named cross, offset, mask, aim, stillness. Tap float indicates the maximum offset of the weapon when the sight is not open and the weapon is held, sighted, and stationary. New variable named cross, offset, min, aim, move. Tap float indicates the minimum offset of the weapon when the sight is not open and the weapon is held, sighted, and moving. New variable named cross, offset, mask, aim, move. Tap float indicates the maximum offset of the weapon when the sight is not open and the open is held, sighted, and moving. New variable named vertical offset. Tap float indicates the value of the offset of the vertical shake after firing the weapon. New variable named horizontal offset. Tap float indicates the value of the offset of the horizontal shake after firing the weapon. New variable named init velocity. Tap float indicates the initial velocity of the weapon's rounds. New variable named 100 m velocity. Tap float indicates the velocity of weapons bullets when they travel to 100 meters. New variable named 300 m velocity. Tap float indicates the velocity of weapons bullets when they travel to 300 meters. New variable named 500 m velocity. Tap float indicates the velocity of the weapon's bullets when they travel to 500 meters. New variable named walk speed PER. Tap float indicates that the character's movement speed is reduced to a percentage value when the character holds the weapon. That's it for weapons-related data structure. You may not know much about what these variables do, but we will explain them in more detail when they are needed. Save, close. Create the date table in the date table items folder. And select ST item weapon. Name it DT item weapon. Open. Add rule. Set rule name to 1. Indicates the weapon number. Set name to M416. Set the icon to icon weapon HK416. Set the big icon to weapons gun HK416. Set the thumbnail to thumbnails M4. Set the use bullet number to 1. Set the magazine capacity to 30. Set the damage value to 5. Set the fire interval to 0.091. Set the magazine change time to 2.2. Set the magazine change time to 0. Because the M4 is an automatic rifle and does not need to change bullets every time you fire. Set auto mode to true. M4 can be switched to full auto mode. Set the static model to HK41601. Set the skeletal model to SKM weapon M4. Set default magazine to MACC MAG default M4. Set the default synth MACC synth default M4. Set the default backstock to MACC backstock default M4. Set the fire sound to wave fire M4. Set the firing sound for installing the silencer to while, fire, M4, spacer. The setting can be set to mount the set. Set the muzzle to be mounted. Set mount the magazine. The setting for mounting the backstock is enabled. Set gross offset mean stillness value to -25. Set gross offset max stillness value to 25. Set gross offset min mu value to -95. Set gross offset max mu value to 95. Set gross offset min aim stillness value to -10. Set gross offset max aim stillness value to 10. Set gross offset min aim mu value to -35. Set gross offset max aim mu value to 35. Set the vertical offset to -0.25. Set the horizontal offset to 0.1. Set the initial velocity to 88,000 in centimeters per second. Set the bullet's 100 meter velocity to 75,000 in centimeters per second. Set the bullet's 300 meter velocity to 69,200 in centimeter per second. Set the bullet's 500 meter velocity to 60,000 in centimeter per second. Set the movement speed down to 95%. Add row. Set row name to 2. Set name to AKM. Set the icon to icon weapon AK-47. Set the big icon to weapons gun AK-47. Set the thumbnail to thumbnails AK. Set the use bullet number to 2. Set the magazine capacity to 30. Set the damage value to 10. Set the fire interval to 0.11. Set the magazine change time to 2.5. Set the magazine change time to 0. Set auto mode to true. Set the static model to AK-4701. Set the skeletal model to SKM weapon AK. Set default magazine to MACC MAG default AK. AK do not need a default set. AK do not need the default backstock. Set the fire sound to wall fire AK. Set the firing sound for installing the silencer to wall fire AK spacer. The setting can be set to mount the set. Set the model to be mounted. Set to mount the magazine. The setting for mounting the backstock is disabled. Set gross offset mean stillness value to -25. Set gross offset max stillness value to 25. Set gross offset min mu value to -95. Set gross offset max mu value to 95. Set gross offset min aim stillness value to -10. Set gross offset max aim stillness value to 10. Set gross offset min aim mu value to -35. Set gross offset max aim mu value to 35. Set the vertical offset to -0.3125. Set the horizontal offset to 0.1. Set the initial velocity to 71,500 in centimeter per second. Set the bullet's 100 meter velocity to 60,000 in centimeter per second. Set the bullet's 300 meter velocity to 54,500 in centimeter per second. Set the bullet's 500 meter velocity to 46,900 in centimeter per second. Set the movement speed down to 95%. Add row. Set row name to 3. Set name to AWM. Set the icon to icon weapon AWM. Set big icon to weapons gun AWM. Set the thumbnail to thumbnails AWM. Set the use bullet number to 2. Set the magazine capacity to 5. Set the damage value to 100. Set the fire interval to 0. Sniper rifles must be changed without firing a single shot. Set the magazine change time to 3. Set the magazine change time to 1.23. Set auto mode to false. Set the static model to AWM01. Set the skeletal model to SKM weapon AWM. Set default magazine to MACC MAG default AWM. AK do not need a default set. AK do not need the default bastock. Set the fire sound to wall fire AWM. Set the firing sound for extending the silencer to wall fire AWM suppressor. The setting can be set to mount the set. Set the muzzle to be mounted. Set to mount the magazine. The setting for mounting the basket is disabled. Set gross offset mean stillness value to -25. Set gross offset max stillness value to 25. Set gross offset mean move value to -95. Set gross offset max move value to 95. Set gross offset mean aim stillness value to -10. Set gross offset max aim stillness value to 10. Set gross offset mean aim move value to -35. Set gross offset max aim move value to 35. Set the vertical offset to -0.5. Set the horizontal offset to 0.2. Set the initial velocity to 91,000. Set the bullet's 100 meter velocity to 85,700. Set the bullet's 300 meter velocity to 81,800. Set the bullet's 500 meter velocity to 76,900. Set the movement speed down to 90%. Save. Open SD atom weapon. Add variable. Named can grip. Type boolean. Used to indicate whether the weapon can be mounted with a grip or not. Move to under whether or not the method can be mounted. Save. Close. Select the M4 weapon and set can mount grip to true. The other two weapons are not available for mounting the grip. Save. For now, we are only making these 3 guns. The weapon date table is completed. That's it for this lesson. Thanks for watching, and we'll see. Hello everyone, I'm Big Cat. In this lesson, we're going to create an ammo date table. Create structure in the data table structure atoms folder, and name it st atom ammo. Open. The first variable is named name, and the type is test. It is used to indicate the name of the bullet. New variable named pickup mesh. Type static mesh object reference. This will represent the model of this bullet when it is on the ground. New variable named pickup amount. Type integer. Used to represent the number of bullets in a stack. New variable named icon. Type texture 2D object reference. Used to represent the bullet icon. New variable named weight. Type integer. Used to represent the weight of one bullet. The weight will affect the pack capacity. Save. Close. Create datetable in the datetable atoms folder. Select st atom ammo. Name it dt atom ammo. Open. Add row. Set row name to 1. Indicates the bullet number. Set name to 5.56 mm. Set pickup model to mprop ammo box 556. Set the number of stacks to 30. Set icon to icon ammo 556 mm. Set the weight to 1. Add row. Set row name to 2. Set name to 7.62 mm. Set pickup model to mPurple ammo box 762. Set the number of stacks to 30. Set icon to icon ammo 762 mm. Set the weight to 1. Currently, we only have these two types of bullets. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to create weapon accessories datetable. Since there are many types of weapon accessories, before making the weapon accessories datetable, create an enumeration to represent the type of accessories. Create the enumeration in the Data's annual folder and name it eWeaponACC tab. Open. New. Name it Sight. Indicates that this tab is a scope. New. Name it Muzzle. Indicates that this tab is muzzle. New. Name it Free Grip. Indicates that this tab is a grip. New. Name it MAG. Indicates that this tab is a magazines. New. Name it Backstock. Indicates that its tab is a rifle backstock. Save. Close. Create structure in the Data's table structure items folder, named ST-Item Weapon ACC. Open. The first variable is named Name, and tab Test, used to indicate the weapon accessories name. New variable, named Tab, of tab eWeaponACC tab. Tab 2 indicates the type of the accessories. New variable, named Weapon IDs. Tab Test Array indicates the weapon number that can be used with these accessories. New variable named Weight. Tab Integer indicates the weight of the accessories. New variable named Static Mesh. Tab Static Mesh Object Reference, a model file to represent the accessories. New variable named Static Mesh 2. Tab Static Mesh Object Reference. There are some accessories mounted on different weapons that use different modes. New variable named Icon. Tab Texture 2D Object Reference. Icon file to represent the accessories. New variable named Sight Multiple. Tab Integer indicates the zoom level accessories is a set. New variable name is Suppressor. Tab Boolean indicates if the accessories have a silencer effect or not. New variable named is not flash. Tab Boolean indicates whether the accessories has a no flash effect or not. New variable named Clip Red. Tab Float indicates if the accessories affects the rate at which magazines are changed. New variable named Clip Capacity. Tab Integer. This will indicate the magazine's capacity of the accessories. New variable named Vertical ADG PER. Tab Float indicates the percentage of vertical shake adjustment for these accessories. New variable named Horizontal ADG PER. Tab Float indicates the percentage of horizontal shake adjustment for these accessories. You may not understand what these values do now. It does not matter. We will explain them in detail when we use them later. Save, close. create datetable in the datetable items folder, and select st item weapon ACC. Name it dt item weapon ACC. Open. Add rule. Set rule name to 1. Indicates the weapon accessories number. Set name to holographic set. Set type to set. Do not set the available weapon number. If there is no available weapon number, which means the accessories are available for all weapons, set the width to 10. Set the model to MACC set EO teach. Set the icon to icon attach upper hollow set. Set the set multiplier to 1. Not all the other parameters have anything to do with the set and do not need to be set. Add rule. Set rule name to 2. Set name to 4x scope. Set type to set. Do not set the available weapon number. The accessories are available for all weapons. Set width to 20. Set model to MACC set ACOG. Set the icon to icon attach upper ACOG 01. Set the set multiplier to 4. Other parameters are not related to the set and do not need to be set. Add rule. Set rule name to 3. Set name to compensator DMR. Set type to muzzle. Set available weapon number to 1. 2. Balls, M4 and AK are available. Set width to 5. Set model to MACC muzzle compensator rifle. Set the icon to icon attach muzzle compensator large. Set the velocity shake adjustment percentage to 0.25, indicating a 25% reduction in vertical shake. Set the horizontal shake adjustment percentage to 0.25. This means the horizontal shake is reduced by 25%. Add rule. Set rule name to 4. Set name to compensator SR. Set type to muzzle. Set available weapon number to 3. AWM is available. Set width to 5. Set model to MACC muzzle compensator SR. Set icon to icon attach muzzle compensator sniper rifle. Set vertical shake adjustment percentage to 0.25, indicating a 25% reduction in vertical shake. Set horizontal shake adjustment percentage to 0.25. This means the horizontal shake is reduced by 25%. Add rule. Set rule name to 5. Set name to flash header DMR. Set type to muzzle. Set available weapon number to 1 and 2. AWM can be used. Set width to 5. Set model to MACC muzzle flash rifle. Set the icon to icon attach muzzle flash header. Set no flash to true. Set the vertical shake adjustment percentage to 0.1, indicating a 10% reduction in vertical shake. Add rule. Set rule name to 6. Set name to flash header SR. Set type to muzzle. Set available weapon number to 3. AWM is available. Set width to 5. Set model to MACC muzzle flash SR. Set the icon to icon attach muzzle flash header sniper rifle. Set no flash to true. Set the velocity shake adjustment percentage to 0.1, indicating a 10% reduction in vertical shake. Add rule. Set the rule name to 7. Set name to suppressor DMR. Set tab to muzzle. Set available weapon numbers to 1 and 2. M4 and AK can be used. Set weight to 5. Set model to MACC muzzle silencer rifle. Set model 2 to MACC muzzle silencer AK. It means if it is AK used model 2. Set icon to icon attach muzzle suppressor large. Set muzzle silencer AK to true. Set the vertical shake adjustment percentage to 0.05, indicating a 5% reduction in vertical shake. Add row. Set row name to 8. Set the name to suppressor SR. Set tab to muzzle. Set available weapon number to 3. AWM is available. Set weight to 5. Set model to MACC muzzle cylinder SR. Set the icon to icon attach muzzle suppressor sniper rifle. Set silencer to true. Set the vertical shake adjustment percentage to 0.05. Add row. Set row name to 9. Set name to vertical for a grip. Set tab to free grip. Set available weapon number to 1. Set weight to 5. Set model to MACC vertical grip. Set the icon to icon attach lower for a grip. Set the vertical shake adjustment percentage to 0.25. Add row. Set row name to 10. Set name to angled for a grip. Set tab to frigate. Set available weapon number to 1. M4 is available. Set weight to 5. Set model to MACC angle for a grip. Set icon to icon attach lower angled for a grip. Set the horizontal shake adjustment percentage to 0.3. Add row. Set row name to 11. Set name to extended mag DMR. Set tab to magazines. Set available weapon number to 1. 2. M4 and AK are available. Set weight to 5. Set model to MACC mag extended M4. Set model 2 to MACC mag extended AK. Set icon to icon attach magazines extended large. The magazine's rate is set to 1, which means 1x speed, which is the normal speed. The magazine capacity is set to 40. Add row. Set row name to 12. Set name to extended mag SR. Set tab to magazines. Set available weapon number to 3. Set weight to 5. Set model to MACC mag extended AWM. Set the icon to icon attach magazines extended sniper rifle. Set the magazine's rate to 1. The magazine's capacity is set to 40. Add row. Set row name to 30. Set name to quick draw mag DMR. Set tab to magazines. Set available weapon number to 1, 2. Set weight to 5. Set model to MACC mag quick M4. Set model 2 to MACC mag quick AK. Set icon to icon attach magazines quick draw large. The magazine's rate is set to 0.8, which means that the default 80% time is used. The magazine's capacity is set to 30. Add row. Set row name to 40. Set name to quick draw mag SR. Set tab to magazines. Set available weapon number to 3. Set weight to 5. Set model to MACC Mag, Quick AWM. Set the icon to icon attach magazines, Quick Draw Sniper Rifle. Set the magazine's rate to 0.8. The magazine's capacity is set to 30. Add row. Set the row name to 50. Set name to ext dot quick draw mag DMR. Set tab to magazines. Set available weapon number to 1, 2. Set the weight to 5. Set model to MACC Mag, Quick Extended M4. Set model 2 to MACC Mag, Quick Extended AK. Set the icon to icon attach magazines, Extended Quick Draw Large. The magazine's rate is set to 0.8. The magazine's capacity is set to 40. Add row. Set row name to 60. Set name to ext dot quick draw mag FR. Set tab to magazines. Set available weapon number to 3. Set weight to 5. Set model to MACC Mag, Quick Extended AWM. Set the icon to icon attach magazines, Extended Quick Draw Sniper Rifle. The magazine's rate is set to 0.8. The magazine's capacity is set to 40. Add row. Set row name to 17. Set name to Tactical Stock M4. Set tab to bat stock. Set available weapon number to 1. Set weight to 5. Set model to ACC bat dog 01 M4. Set the icon to icon attach stock AR composite. Set the vertical shake adjustment percentage to 0.15. Set the horizontal shake adjustment percentage to 0.05. For now, we have these weapon accessories. The weapon accessories table is created. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to create equipment data table. Before creating the equipment data table, let's create the item tab enumeration. Create the enumeration in the enu folder. Name it e-item tab. Open. New. Named weapon, indicating that this tab is a weapon. New. Named accessories, means this tab is weapon accessories. New. Named ammo. The name ammo means that this tab is for bullets. New. Named health, means this tab is medicine. New. Named burst, means this tab is energy-related items. New. Named helmet. The name helmet means that this tab is helmet. New. Named vest. The name vest means that this tab is bulletproof vest. New. Named backpack. The name backpack means that this tab is a backpack. New. Named fashion. Named fashion to indicate that this tab is a fashion. Save. Close. Create structure in the Data's Table Structure Items folder and name it ST Item Equipment. Open. The first variable is named name, and the tab is text. It is used to indicate the name of the equipment. New variable is named tab. Tab e-item tab, used to indicate the tab of this equipment. New variable named static mesh. Tab static mesh object reference, the model file used to represent the equipment. New variable named icon. with a reference to a texture 2D object, an icon file to represent the equipment. New variable named subness with a texture 2D object reference. The subness file used to represent the equipment. New variable named capacity. Cap integer used to represent the capacity of the backpack if the item is a backpack. Save, close. Create dataable in the dataable items folder. And select ST item equipment. Name it DT item equipment. Open. Add row. Set row name to 1, indicating the equipment number. Set name to helmet level 1. Set the tab to helmet. Set model to M-prop helmet 1. Set icon to icon equipment hand E02. Set the thumbnail to helmet level 1. Set the capacity to 0. Add row. Set row name to 2. Set name to helmet level 2. Set tab to helmet. Set model to M-purple helmet 2. Set icon to icon equipment head F02. Set the thumbnail to helmet level 2. Set the capacity to 0. Add row. Set row name to 3. Set name to helmet level 3. Set the tab to helmet. Set model to M-purple helmet 3. Set icon to icon equipment head G01. Set the thumbnail to helmet level 3. Set the capacity to 0. Add row. Set row name to 4. Set name to police vest level 1. Set tab to vest. Set model to M-purple armor 1 female. Set icon to icon equipment armor E01 level 1. Set the thumbnail to vest level 1. Set the capacity to 0. Add row. Set row name to 5. Set name to police vest level 2. Set tab to vest. Set model to M-purple armor 2 female. Set icon to icon equipment armor D01 level 2. Set the thumbnail to vest level 2. Set the capacity to 0. Add row. Set row name to 6. Set name to military vest level 3. Set tab to vest. Set model to M-purple armor 3 female. Set icon to icon equipment armor C01 level 3. Set the thumbnail to vest level 3. Set the capacity to 0. Add row. Set row name to 7. Set name to backpack level 1. Set the tab to backpack. Set model to M-purple backpack 1 female. Set icon to icon equipment back E01. Set thumbnail to backpack level 1. Set the capacity to 50. Add row. Set row name to 8. Set name to backpack level 2. Set tab to backpack. Set model to M-purple backpack 2 female. Set icon to icon equipment back F02. Set the thumbnail to backpack level 2. Set the capacity to 100. Add row. Set row name to 9. Set name to backpack level 3. Set tab to backpack. Set model to purple backpack 3 female. Set icon to icon equipment bag C01. Set thumbnail to backpack level 3. Set capacity to 150. That's all the equipment we have for now. Save. That's it for this lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to make medicines date table. There are two types of medicines. One is to restore the health value directly, and the other is to increase the energy value, which is then converted into health value. First, let's make a medicines date table that directly restores health value. Create structure in the data's table structure items folder and name it st_item health. Open. The first variable is named name. Tab text. It is used to indicate the name of this medication. New variable named static mesh. Tab static mesh object reference, the model file for this medicine. New variable named icon. Tab texture 2D object reference, an icon file to represent the medicine. New variable named weight. Tab integer, indicate the weight of the medicine. New variable named use time. Tab float, indicate the number of seconds needed to use the medicine. New variable named value. Tab float, indicates the number of health that can be restored by the medicine. New variable named limit. Tab float, used to indicate the maximum value to which the medicine can be restored. Save, close. Create date table in the date table items folder. And select st_item health. Name it dt_item health. Open. Add row. Set row name to 1, indicating the medicine number. Set name to first aid kit. Set the model to purple health first aid pack. Set icon to icon health first aid. Set the weight to 10. Set the use time to 5 seconds. Set the recovered health value to 75. Set the recovered maximum value to 75. Add row. Set row name to 2. Set the name to Medicate. Set model to purple health Medicate. Set icon to icon health Medicate. Set weight to 20. Set use time to 10 seconds. Set the recovery health value to 100. Set the maximum value after recovery to 100. Save and close. Next, make the energy-related date table. Create the structure in the data's table structure items folder and name it st_item burst. Open. The first variable is named name, and the tab is text, indicates the name of this energy item. New variable named static mesh. Tab static mesh object reference, indicates the model file for this energy object. New variable named icon. Tab text 2D object reference, represent the icon file of this energy object. New variable named weight. Tab integer, indicates the weight of the energy object. New variable named use time. Tab float, indicates the number of seconds it takes to use the energy item. New variable named burst value. Tab float, indicates the total energy value that can be added to this energy item. Save, close. Create datetable in the datetable items folder. And select st_atom burst. Name it dt_atom burst. Open. Add row. Set row name to 1, indicating the energy atom's number. Set name to energy drink. Set the model to purple burst drink. Set icon to icon burst energy drink. Set weight to 4. Set use time to 4 seconds. Set the increase energy value to 30. Add row. Set row name to 2. Set name to painkiller. Set model to purple burst pulse drawer. Set icon to icon burst painkiller. Set weight to 10. Set use time to 6 seconds. Set the increase energy value to 60. Add row. Set row name to 3. Set name to adrenaline syringe. Set the model to purple burst injection. Set icon to icon burst adrenaline syringe. Set the weight to 20. Set the use time to 8 seconds. Set the increase energy value to 100. Energy-related items data addition is complete. Save and close. That is for this lesson. Thanks for watching, and we'll see you next. Hello everyone, I'm Big Cat. Starting in this lesson, we are making an atom system. In this lesson, we'll start by looking at the atom framework. I've hidden variable types, function arguments, and return values for greater clarity in this framework diagram. The core of the inter-atom framework is to organize these objects by inheritance. The atom base is the most basic object, and all atom objects need to inherit from this object. The advantage of this is that we can use the base class directly when passing objects, thus avoiding the hassle of type conversions. The base class variables are the most base properties of an atom and are needed for all atoms, so that in most cases we can manipulate objects directly using the base class type. Objects are distinguished by state, one before they are acquired and one after they are acquired. Pre-acquired refers to the object when the atom is on the ground, and post-acquired refers to the object after the character picks it up from the ground. Pick-up base is the base class of the pre-acquired atom object. All pre-acquisition atoms need to inherit this object. The functions implemented in the ground atom base class are all functions related to how atoms change when the character collides with them. The atoms that can currently be obtained from the ground are weapons, weapon accessories, bullets, equipment, health restores, fashions, and energy restores. These atom objects all inherit pick-up base class objects so that they all automatically get the effect of interacting with the character on the ground. Except for the pick-up atom object, all other objects are objects that are acquired when the atom is acquired. Let's look at the atom use first. The atom use object is the base class object for all atoms that can perform use actions. It takes a certain amount of time to use an atom, and the use operation logic is implemented in this base class. Atom health is an atom object that restores health value, and atom burst is an atom object that restores energy value. In addition to these objects, there is a weapon object in which weapon-related logic is implemented, such as fire, stop fire, change magazines, and so on logic. There is also a weapon accessories object, an ammo object, and an equipment object. The objects included in this class are basically in this framework, and the content and methods of each object implementation will be explained in detail later in the class. That's it for this lesson. Thanks for watching, and we'll see you next. Hello everyone, I'm Big Cat. In this lesson, we are going to create an atom-based class. Create a new folder in Blueprint named Atoms. All atom objects will be placed under this folder. Create a Blueprint class. Select Actor. Name it AtomBase. Open. The Actor object will have a default scene root component by default. Add a scene component and override this default component. New variable named AtomTab. Of tab eAtomTab. The category is public, indicates AtomTab. New variable named ID. Tab name. Category public, then atom number. New variable named ISN. Type string. Category public indicates the unique atom number. This number will be generated when the atom is created and will not be the same as any other atom. New variable named name. Tab text. Category public. The name of the atom. New variable named amount. Of tab integer. And category public indicates the number of atoms. Some atoms are always 1, such as weapons, equipment, etc. Some atoms are stackable. Some atoms can be stacked, such as bullets, medicines, and so on. New variable named character_ref. Tab myCharacter. It represents a reference to the myCharacter object. This variable will only be used in subclasses, so set the category to protected. New variable named controllerRef. Of tab myPlayerController. This represents a reference to the myPlayerController object. This variable will only be used in subclasses, so set the category to protected. Set the public option to true for ID, SN, and amount, when the instance of these three variables can be modified and generated. When these two options are set to true for the variable, you can set the variable directly when creating the actor object. Compile. Open event graph. Add the spawn actor node. Select class as AtomBase. As you can see, these three variables can be set directly at the time of creation. No matter what atom is created, these three variables need to be set at creation. So, let's export these three variables to spawn. Delete node. Initialize the object reference in the beginPlay event. Get player character. Convert to myCharacter tab. Set to the character_ref variable. Get player controller. Convert it to myController tab. Set to the controller_ref variable. Add comment. Create function named init. This function will only be called in subclasses, so set the category to protected. New input parameter named AtomTab. Tab eAtomTab. New input parameter named name. Tab text. Set variables by input parameter. Add a function named getWeight. Category set to public, used to get the weight of the atom object. New output parameter named weight. Type integer indicates weight value. Not all items have a weight. Only items that can be put in a backpack have a weight. So, in the getWeight function of the base class, the weight is returned directly to 0. Items that have weight are overridden in the item subclass with this function, since you only need to get the return value directly. Make the function pure. Next, create the update item amount function. Add the function, name it update amount, and set the category to public. Add an input parameter named add, and type boolean. It is used to indicate whether this update is an add amount or not. Add an input parameter named reduce of type boolean, used to indicate whether this update is a reduction in the amount. Add an input parameter named amount. Type integer, used to indicate the amount of the update. Determine if the amount is an add value. If the amount is added, increase the amount in the current object. If it is not add amount, determine if it is decrease amount. If the number is decreasing, decrease the number in the current object. If it is neither add nor decrease, then it proves that the amount is set directly. The object base class is needed to implement these functions. Compile, save. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making pickup base classes. Create a new folder in Atom and name it pickup. All ground item objects are placed under this folder. Create an actor and name it pickup base. Open it. Click Class Settings. In the Details panel, set the parent class to item base. Compile, save. Next, create the component. Add a static mesh component. This is used to display the item's model. Add a widget component to the static mesh component. Named UI, used to display the UI. Add a static mesh component to the static mesh component and name it outline. This component is used to make the height, lighting, and outline features of the model. Add a box collision component to the scene. This is used for collision detection with characters. Add a variable named UI prefix. Type text. This variable is used to represent the text prefix that picks up the UI. Subclasses will set this UI prefix depending on the type. Category is protected. Select the static mesh component. Set collision preset to no collision. This component is only responsible for displaying the item model and does not need to have any collision functionality. Select the outline component. Set the collision preset to no collision. This component is only responsible for displaying outline effects. No collision functionality is required. Create a function named initPickup. The function of this function is to initialize the pickup related functions. Set the category to protected. Create parameters as per the init function. Add input variable named UI prefix. Tab text. It means to pick up the UI text prefix. Add an input variable named static mesh. Tab static mesh object reference indicates the model object to be displayed. Set the variables by input parameters. To see the preview effect, set a weapon for the static mesh component. Open the level. Drag a pickup base object into the level. Run the game. Although the model is displayed, it is floating in the air. We want the atom to fall to the ground when it is created automatically. How to achieve this? We can fire a ray down from the atom's position, record the position when it hits the ground, and set that position to the atom. We want the ray here to only glide with the ground. So we need to add an object channel. What is an object channel? Select any model in the level. Find the collision preset and select Custom. This object tab property is the object channel. Click. You can see that the system sets some object channel tabs by default. Next, we add a new tab. Restore the different settings. Open the Project Settings panel. Select Collision. Create a new object channel. The name is set to Land, which means it is ground. This block means that by default, other objects can land with the land object. Confirm. This way, we have created an object channel tab. Open the level. Select Land Space. Set the collision preset to Custom. Turn on collision. Set the object tab to the land we just created. Select Collision All. Save the level. Go back to the pickup base. Call the line trace for object node in the begin play event. This node aims to fire a ray and then send a collision with the specified typed object. The starting point of the ray is set to the current actor's position. The end position is then set. Get the current character's position first. Expand. Also expand the endpoint in the line trace node. Set X, Y. Z plus a minus 1000 is added to set to the line trace node. The ground is always underneath the atom, so the ray end position is plus a minus 1000. Then make an array. The first element of the array is selected as the length type. To see the test result, set the Draw Debug Length tab to 4 duration. The draw time is 500 seconds. Expand the collision information. Set the location value to the current character. Note here that since the base class also has the begin play event and implements the function in the begin play of the base class, So you need to execute the beginPlay event of the parent class in the child class. Otherwise, the beginPlay event in the parent class will not trigger. Right-click, select Add Call to Parent function. Execute the parent class logic before executing the logic. Run the game. The object falls to the ground. The read line is the array. It should be noted here at the moment we are testing the weapon mod is fun, but other types of item models may have problems. Due to the different anchor positions of the model will cause the display to be off. This will be done with later when doing pickup subclass. Set the draw debug line tab to none. Add comment. Next, make the item and character overlap event. Open the viewport panel. The box is the collision area. Select the box component and set the box extent to 220, 220, 100. Set the collision preset to custom. First, click to ignore all collisions. Set the overlap with pawn object to be able to overlap. Add the begin overlap event and overlap event. Determine if the object that enters the collision range of the item is current character object. If it is the current character object, send the event. Add the event named onBeginOverlap. Indicates that the actor has entered the collision range of the item. Add an argument named PickUpObject of type PickUpBase object reference. Call this event. Set the parameter to itself. In the endOverlap event, determine if the removed item collision range field is the current character object. If it is the current character object, send the event. Add the event named onEndOverlap. Indicates that the actor has moved out of the object collision range. Add a parameter named PickUpObject. Type PickUpBase object reference. Call this event. Set the parameter to itself. Add comment. Next, make the item outline feature. We will use post-processing to outline and headland the item. Open the level. Enter post and drag post-process value into the level. Named offline post-process volume. Find the render feature. In the post material area, add data. Select the tab as resource reference. Set the material to pp outliner inst. As we can see in the level, post-process volume has volume in the level. Only objects that are within the volume are affected by this post-process volume. Our pickup object could appear anywhere in the level, so we need to set the volume size. Find the settings. Select the infinite extent option. When checked, the post-process volume will affect all positions in the level. Save the level. Go back to the pickup base. Create a function, name it enabled outline. Set the tab to public. Add an input parameter, name it enabled. of type boolean, used to indicate if highlighting is on. Determine the state of enable. If highlighting is enabled, call the setRenderCustomDice function of the static mesh component. Value is set to true. If highlighting is off, copy the function. Value is set to false. Compile and save. Next, test the outline effect. Call the start outline when the character enters the collision range. Call off outline when the character moves out of item collision range. Select the box component. Set head in game to false. This way, you can see the result more clearly. Run the game. When the character walks into the collision range of an item, the item starts to highlighting. When the character moves out of item collision range, the item turns off the highlighting. Delete the test node. Select the static mesh component and set the model to empty. Select the box component and choose head in game. Compile, save. Open the level and delete the pickup base object. Save. That is for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to make weapon pickup objects. First, create a weapon pickup object. Create an actor in the blueprint items pickup folder. Name it pickup weapon. Open. Open class settings. Select pickup base as the parent class. New variable named ammo. Type integer indicates the number of bullets in the current weapon magazines. Set instance enabled and expose on spawn to true. Open construction script function. This function will be executed when the object is created. Some initialization related logic can be done here. Find the weapon data by ID in the weapon data table. Promote the data as a variable, named datas, and category as public. Expand the structure. Call the initPickup function. Set the variable. Select the expanded structure. Click Head Unconnected Hands in the Detail panel. Set the Pickup UI prefix to Equip. Note that there is a space at the end. Compile and save. Next, let's test if we can generate the weapon pickup object correctly. Open the level blueprint. Create the spawn actor node. Set class to pick up weapon. Set ID to 1. Set SN to 111. Make a transform. And set the location value. This value, we can drag an actor into the level and record the location. Run the game. You can see that the weapon pickup object was successfully created. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Everyone, I'm Big Cat. In this lesson, we're going to create weapon accessories to pick up object. First, we will create a weapon accessories pickup object. Create an actor in the pickup folder. Name it pickup weapon ACC. Open class settings. Select pickup base as the parent class. New variable, named ACC type. Tap Weapon Accessories tab in your agent. Open Construction Script function. Find the weapon accessories data by ID in the weapon accessories data table. Promote the data as a variable. Named datas. And category as public. Expand the structure. Set the accessories tab. Call the init pickup function. Set the variable. Click Hide Unconnected Pins in the Detail panel. Set the Item tab to Weapon Accessories. Set the Pickup UI prefix to Pickup. Note that there is a space at the end. Next, you need to rotate the angle for a part of the weapon accessories. Open the weapon accessories data table. First, find the vertical grip. Find the model and drag the model into the level. Since the vertical grip's anchor point is at the top of the enter model, the model is shown below the ground. After dragging it into the level, adjust the x-axis rotation angle of the model to 90 degrees. The model can be displayed correctly. Drag the angle grip into the level and adjust the model's x-axis rotation angle to 90 degrees. The model can be displayed correctly. Go back to Pick Up Weapon ACC. Switch Accessories tab. Set the model's rotation. X to -90. Go back to the Accessories data table. All magazines as well as the buttstock have the same problem. Go back to Pick Up Weapon ACC. Set rotation to the same for the magazines and the buttstock. Add comment. Next, adjust the landing position of the weapon parts. Find the weapon accessories model resource. Drag the muzzle accessories into the level, and you can see the muzzle's anchor point in the middle of the model. Drag a grip model into the level. Drag a magazine model into the level. Drag in a buttstock model. Rotate their x-axis by -90 degrees. At this point, their anchor point is also in the middle of the model. Drag in a model of the site. The sight model's anchor point is the bottom. Go back to the event graph of the weapon accessories pickup object. Determine in the begin play event if it is not a sight. Get the model's border. Call the add actor local offset node. This node is the cumulative position value. Set the z value to the cumulative z value. Add comment. Override to get the weight function. Get the weight in the weapon data table by ID. Compile, save. Next, let's test if we can generate the weapon accessories pickup object correctly. Open the level blueprint. Set class to pick up weapon ACC, ID to 1. Run the game. Successfully create the sight pickup object. Set the ID to 3. Run the game. Successfully created the muzzle pickup object. Set the ID to 9. Run the game. Successfully created a grip pickup object. Set the ID to 70. Run the game. Successfully created the bastock pickup object. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to create ammo pickup objects. Create an actor in the pickup folder. Name it pickup ammo. Open. Open class settings. Select pickup base as the parent class. New variable named single weight. Type integer. Category private indicates the weight of a single round of bullet. Set it to private. Open construction script function. Find the ammo data by ID in the ammo data table. Promote the data to a variable named datas. Category as public. Expand structure. Set the default number and single white. Call the init pickup function. Set the variables. Click Hide unconnected pins in the Details panel. Set the item type to ammo. Set the pickup UI prefix to pickup. Note that there is a space at the end before setting the number of bullets. Determine if the number of bullets is 0. If it is 0, it means that the bullet amount was not set at the time of creation, and the default bullet amount is set through the date table. If the number is not 0, the bullet count was already set when the bullet was created, and there is no need to set the bullet count. Compile, save, override to get the weight function. Multiply the number of bullets by the weight of one bullet to get the current object's total weight. Compile, save. Next, let's test if we can generate the ammo pickup object correctly. Open the level blueprint. Set the class to pick up ammo. Set the ID to 1. Run the game. You can see that the ammo pickup object was successfully created. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making equipment pickup objects. Create an actor in the pickup folder. Name it pickup equipment. Open. Open class settings. Select pickup base as the parent class. New variable named equipment tab. Tab item tab. Category is private. Select private. Open construction script function. Find the equipment data by ID in the equipment data table. Promote the data to a variable named datas. Category public. Expand structure. Set the equipment tab. Call the init pickup function. Set the variable. Click Hide Unconnected Pins in the Details panel. Pickup UI prefix set to switch to. Note that there is a space at the end. Compile, save. Next, adjust the position of the equipment landing. Find the equipment model resource. Drag the helmet into the level. You can see the health anchor point at the top of the model. Drag a backpack model into the level. Set the x-axis rotation to 90 degrees. Set the y scale to 0.1. Drag in a bullet-proof vest model. Set the x-axis rotation to -90 degrees. Set the y-axis scaling to 0.1. At this point, their anchor point is basically in the middle of the model. Go back to the event graph of the equipment pickup object. Determine if it is a helmet in the begin play event. Get the model's borders. Call the Add Actor Local Offset node. Set twice the z value to the cumulative z value. Add comment. Next, let's test if we can generate the equipment pickup object correctly. Open the event blueprint. Set the class to pick up equipment. Compile. Run the game. You can see that the equipment pickup object was successfully created. Set the ID to 4. Run the game. The bulletproof vest can be shown, but this form is currently too large, and we want to press it flat. Go back to pick up equipment construction. Determine if it is currently a bulletproof vest. If it is a bulletproof vest, first, scratch it on the y-axis. Set the y-axis value to 0.1. Then, rotate it minus 90 degrees in the x-axis direction. Run the game. Bulletproof vest is not displayed. Set the X and Z axis scaling to 1. Run the game. We found that the vest has been squashed. Select the transport property when setting rotation. If it's a backpack, you also need to compress the model and rotate it. Add the sequence node. Determine if it's a backpack. Set zoom, copy and paste. Set the x-axis rotation value to 90. Add comment. Compile. Save. Open level blueprint. Set the ID to 7. Run the game. Backpack displays correctly. That's it for this lesson. Thanks for watching, and we'll see you next. Hello everyone, I'm Big Cat. In this lesson, we're going to make health pickup objects. Create an actor in the pickup folder. Name it pickup health. Open. Open class settings. Select pickup base as the parent class. Open construction script function. Find the health data in the health data table by ID. Promote the data as a variable named datas, and category as public. Expand the structure. Save the weight to an object named single weight. Category as private. Indicates the weight of a single atom. Call the init pickup function. Set the variable. Select the expanded structure. Click Head Unconnected Pins in the Details panel. Set the Atom tab to Health. Set the Pickup UI prefix to pick up. Note that there is a space at the end. Compile, save. Override to get weight function. Multiply the number of items by the weight of a single item to get the current object's total weight. Compile, save. Next, let's test if we can generate the health pickup object correctly. Open the level blueprint. Set the ID to 1. Set the class to pick up health. Run the game. You can see that the health pickup object was successfully created. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to make burst pickup objects. Create an actor in the pickup folder. Name it pickup burst. Open. Open class settings. Select pickup base as the parent class. Open construction script function. Find the burst data in the burst data table by ID. Promote the data as a variable, named datas, and category as public. Expand the structure. Save the weight to an object, named single weight. Category as private. Indicates the weight of a single atom. Call the init pickup function. Set the variable. Select the expanded structure. Click Head Unconnected Pins in the Details panel. Set the Atom tab to burst. Set the Pickup UI prefix to pick up. Note that there is a space at the end. Override to get weight function. Multiply the number of items by the weight of a single atom to get the current object's total weight. Compile, save. Next, let's test if we can generate the burst pickup object correctly. Open the level blueprint. Set the class to pickup burst. Set the ID to 1. Run the game. You can see that the burst pickup object was successfully created. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we're going to make friction pickup objects. Create an actor in the pickup folder. Name it pickup friction. Open. Open class settings. Select pickup base as the parent class. New variable named friction type. Type E friction type. Indicates which position it is friction type. Open construction script function. Find the friction data in the friction data table by ID. Promote the data as a variable, named datas, and category as public. Expand the structure. Set the type. Call the init pickup function. Set the variable. Click Head Unconnected Pins in the Details panel. Set the Item tab to Fashion. Note that there is a space at the end. Compile, save. Next, adjust the fashion landing position. Friend the fashion model resource. Drag a fashion model into the level. Set the x-axis rotation to -90 degrees. Set the y-axis scaling to 0.1. The anchor point is basically in the middle of the model. Go back to the event graph of the fashion pickup object. Get the model's border in the begin play event. Call the add actor local offset node. Set the z value to the simulate z value. Add comment. Next, let's test if we can generate the fashion pickup object correctly. Open the level blueprint. Set the class to pickup fashion. Run the game. You can see that the fashion pickup object was successfully created, but as with the equipment, we need to squash the model. Go back to pickup fashion's version. Set the x-axis rotation value to -90. Set the y-axis scaling to 0.1. Note here that shoes do not need to be squashed in fashion, so you need to remove the shoes. Add comment. Compile, save. Run the game. The model is displayed correctly. Change ID to 8. Run the game. The shoes model is displayed correctly. Compile, save. This completes the creation of all pickup objects. That is for this lesson. Thanks for watching, and we'll see you next lesson.